There we are. Hi everyone, and welcome to DevFest Northeast 2020. So I want to first of all thank everyone for waking up this morning, dragging themselves over to their computer, sitting down, and joining us today for what should hopefully be a really amazing DevFest. Before we get started, I just want to do a couple of housekeeping chores to make sure we all have the best DevFest possible. DevFest is an inclusive event, so we have a few community guidelines we'd like everyone to follow. You can find the code of conduct in the upper right-hand corner of your screen. When you're in one of the social rooms, please turn your camera on, but maintain proper attire. And only unmute your mic when you have something to say. No one wants to hear you chewing, especially if you don't have anything to chew. Finally, if you have any problems, please feel free to contact one of our members of staff or me directly. Now, today we have a slew of wonderful speakers for you, including topics about artificial intelligence, Flutter, Firebase, and baking. The relationship for all of these will become clear later on. This morning, we're going to start off with this, our brief keynote, where I get to talk at you guys for about 15-ish minutes. And then we're going to move into our first talk with Sara Robinson. And then, right after that, we'll be going straight into a talk with Frank van Puffelen about, about live coding in Firebase. After that, we will have a short break where you can get lunch, stretch your legs, change batteries out, whatever you need to do during break. And after you come back from lunch, we're going to have a nice Flutter talk from Scott Stoll, and we're going to finish the day off with automated machine learning. Finally, at the end of the day, we will be releasing a raffle from gifts from our nice sponsors. To be qualified for that raffle, you have to fill out a short form and remember the code of the day. We'll be telling you the code of the day, both at lunch break and at the end of the day. Speaking of our sponsors, we'd like to thank our sponsors. Without them, we wouldn't have anything to give you. No, really, they're the ones who gave us all the swag to give out this year. And what's a conference without swag? For sponsors, we need to thank Practicum by Yandex, JetBrains, O'Reilly Publications, ROI Training, NY Tech Loop, Gazpacho, Developer, one more person who I will mention at lunch because I just dropped my notes. Again, everyone, we're doing this live, so I'm going to drop notes. There should be video pre-rolling, but all right, so if you have any questions, please feel free to reach out to me or to any member of the staff. I am at delay, so if you mention anything in chat, I will probably respond to it about 30 seconds later. If you're joining us from YouTube or Twitch, we are not unfortunately actively monitoring those chats, but we will be checking into them from time to time. Again, delay. So I am seeing some people are having issues getting into the main stage. Please just take and click on the stage icon at the top of your stream if you're joining us on Bevy. If you're on Twitch or YouTube, well, you only have one place to see, and that's the main stage. So you get to look at this wonderful face for the rest of the day. Well, no, you're not going to look at me for all day. If you looked at me for all day, well, we'd all get really bored. And this isn't boring. This is DevFest. I'm seeing we have people in from Texas, Pennsylvania, another Texas, Berlin. Wow, we have people all the way from Berlin. Thank you so much for showing up. We have some people from India. Hello, India. Jersey. Again, we're seeing more people in the chat talking about the raffle. So just remind everyone, the way the raffle works is at lunch and at the end of the day, we will be giving you a secret phrase. You will then fill out a form and include that secret phrase, and we will randomly pick people for the raffle. We will then email you whatever it is you want, be it publication, training coupons, license key signups. We have a whole slew of stuff to give out. I mean, it's literally, I can't remember it all. That's mostly because everyone's like, here, have this stuff. Because we're in difficult times, and we want to make sure that in these difficult times, everyone is able to really get the most they can out of DevFest, even though we can't meet in person. That's why I'm standing here in this shapeless blue void. It's got dots in it. I'm trapped in here, by the way. I can't get out. This is the whole sum of my universe now. All right, let's see. Wow, we got quite a lot of people talking in chat. New Hampshire, hello, New Hampshire. You're actually in the Northeast. Wow. All right, so our first speaker is going to be Sara Robinson, which if we'll cut over to her right now. There we go. So that is our first speaker, who will be joining us hopefully soon.
Hey everyone, can you hear me? I'm going to assume folks can hear me, so I'm going to start to share my screen. Okay, can you all see my slides full screen? Hold on, let me go back to this. Just going to get a confirmation that folks can hear me and see my screen before I get started. If anyone wants to just confirm in the chat. Okay, looks like I'm good to go. With that, I will get started. Hello, everybody. I'm super excited to be here, and thanks to the organizers for putting this event together in a new virtual format this year. I'm going to be talking about baking with machine learning, so it's going to be a fun, lighthearted topic. My name is Sara Robinson. I'm a developer advocate on the Google Cloud Platform team, and I focus on machine learning. You can find me on Twitter at srobtweets, and I have a personal blog at sararobinson.dev. So this is what I'm going to cover in the talk today. I'm going to talk about how I came up with the idea for this kind of silly project, and then how I compiled the data for it to train a machine learning model, putting it all together, and the end result was some baking. I won't spoil the surprise there, but you'll find out at the end. So just to start, I've been baking a lot while hanging out at home the past few months. These are some of the things that I've baked. It's been pretty fun. So next slide. When I first started getting into baking at the beginning of quarantine, I started to wonder if you could combine machine learning and baking. So I posted this on Twitter, and there was quite a bit of interest in it. And the reason that I thought about this is because as I started to make more recipes, I noticed there were some patterns in the ratios of ingredients that you use. And of course, there's a ton of variation in different recipes. But I found this chart and a lot of similar charts all over the internet that showed these ratios that you can stick to. And a lot of professional chefs and bakers know these ratios pretty well, and they use that to improvise and create new recipes. So I wondered if most recipes follow these higher level patterns, could we use machine learning for this? Before I confirmed that, I thought, maybe we don't need machine learning at all. Sometimes people use machine learning when they don't necessarily need to, and I wanted to avoid that problem. Because if you go back here and look at the different ratios, my first thought was maybe we could just write a simple if statement and be done with it. So for example, if the bread ratio, the ratio of flour and water falls between a certain amount, it's bread. Otherwise, it's cookies, and the rest of the if statements you see there. But then I started to realize that this gets a little bit complex. So it might work for basic recipes, that stick to these ratios pretty well. But what if you have a bread that doesn't have yeast, which is pretty common, or a cake that doesn't have eggs, or a sugar-free cookie? So we start to get into all these edge cases, and this is when I realized that this was a pretty good problem for machine learning, because machine learning can identify these higher level patterns and use that to generate predictions on new data. So did some vetting and decided that I wanted to use machine learning. But some of you might be wondering, what is the point of all this? First of all, it's fun, and we could use a little more fun right now. It's a good example of when you might want to use machine learning instead of hard coding rules in traditional programming. It walks you through the process of an end-to-end machine learning solution. And though it is a fairly simple problem, it shows you most of the steps of a machine learning workflow, going from pre-processing your data to getting predictions, to training your model and deploying the model, and then even something fun at the end, which I've newly added to this demo. And something that you can do with this model is get predictions on unknown inputs. So what I mean by that is, it's not that exciting for you to enter a recipe that is bread and for the model to tell you it's bread. But maybe you could use this model to enter the ingredients that you happen to have on hand to see what you could bake, things like that. So that's when it gets a little bit more interesting. So the first step for this was to get some data. I did quite a bit of searching to see if a data set existed for this specific use case, and I couldn't find one. If you do happen to find one, please let me know. I would love to check that out, because the data set that I ended up compiling is pretty small, as you'll soon see. So I just opened up a spreadsheet and started to gather some of my own data. There's no shortage of recipes on the internet. So I tried to figure out what the common ingredients are between different types of recipes. And I decided I only wanted to get recipes of bread, cake, and cookies, not even specific categories of those within those higher level categories. Just wanted to keep it simple with 3 labels. I made some assumptions to simplify the problem, and because I didn't have time to gather thousands of rows of data for this. So I only considered 12 ingredients, which you can see most of here. And these are the model's features. So if you're new to machine learning, the things that you use to train your model are called the features. The label is whatever you're predicting. In this case, that's bread, cake, or cookies. I did assume that all flours are the same, even though I know that they're not. But some recipes call for all-purpose flour, whole wheat flour, all different types of flours if you've got a gluten-free recipe. I just lumped those all into the same category of flour to keep it simple. Same with sugar. There's different types of sugars, but I just added up the amounts in recipes that called for different types and used that as one number. So this is a very small data set. If you've done anything with machine learning before, you'll know that you need ideally a lot of data to train something that's high quality. But I was just playing around with this, and I wanted to see if I could get something that worked, and I didn't have a ton of time to get data. So I have 33 recipes of breads, 33 cake recipes, and 33 cookie recipes. Within each of those categories, oops, one sec. It's got to pop up on my screen. Hold on. Sorry, folks. Hold on one second. Sorry about this technical difficulty. Okay. All right. Sorry about that, folks. Okay, so back to the data set. I tried to get a variety of different types of each of these things. So breads that didn't have yeast, breads that had eggs, things that maybe didn't have sugar, or gluten-free recipes. So I got a good variety, even though there's only 33 per label. And again, disclaimer, you probably want a lot more data than this if you're training a machine learning model. But this was just more of a fun little side project. So I needed to do some data pre-processing. So once I had my spreadsheet of data, I noticed that I had a mix of different types of units. So I had cups, teaspoons, and then eggs, or just eggs. And I couldn't feed all of this into a machine learning model as is, because otherwise it might think, 1 cup of flour, 1 unit of flour was the same as 1 unit of salt, which is absolutely not true. That would definitely lead to some issues in the model. So that was one issue. And the other issue is that all the recipes that I gathered made different amounts. So, you know, one recipe may have made 6 cupcakes, pretty small. Another recipe may have made a giant loaf of bread or a big cake. So I needed to account for the fact that all these recipes make different amounts. So I needed to do some scaling and unit conversion. So I decided to convert everything to cups, just to keep it simple. I know that other parts of the world, people use different measurements. So if this demo is a success, I might end up, you know, adding support for grams. But for now, it's all converted to cups. And then I found a rough conversion for, you know, how many cups 1 egg is equivalent to. It's not perfect, but it seems to work. And then the last thing I did was I converted this to ratios of how much of the entire recipe a particular ingredient was. And this was to account for the scaling issue. And scaling is something that you should often do when you have inputs to a machine learning model. So if you have a model, let's say, you know, that's predicting revenue or sales, maybe you have some numerical inputs that range only from 0 to 1, but another feature that ranges, you know, up to 1 million. You'll want to scale those inputs. Otherwise, it'll be really hard for your model to converge. So I did some scaling here. And next slide. So the resulting data set I had looks something like this. So if it says 0, it just means there isn't any of that particular ingredient in this recipe. And what we end up with is the percentage of each ingredient over the entire recipe. And that's what I wanted to feed into my model. So once I had the data ready and I was ready to build a model, I wanted to look at what tools I could use to do this. So I work on Google Cloud Machine Learning, and I wanted to use some of our cloud tools to build this. So this pyramid here shows all the different, or many of the different machine learning products that we offer on Google Cloud, organized by levels of abstraction. So the products towards the bottom are targeted more towards data scientists, machine learning engineers, folks that might have more ML expertise. And then as we move towards the top, these products are targeted towards application developers that may want a way to add machine learning to their app, but may not necessarily have as much ML expertise as someone writing a model code. So what I chose to use is the ML framework here. That's not a product, but it's just what I would consider the lowest level of building a machine learning model. You're using that framework to write the code for that model from scratch. So I chose to use TensorFlow for this. And once I built a model, I wanted to deploy it. And so I used our managed training and prediction service to do that. So I deployed the model to AI Platform Prediction, which I'll show you in a moment. And I can use that to scalably get predictions on my model. So my TensorFlow model was pretty simple. I'm not going to focus too much on the model code here in the interest of time. But what I really like about TensorFlow is I'm using here what's called the sequential model API. And with TensorFlow's sequential model API, you essentially build your neural network as a stack of layers. So in this code, it's fairly straightforward to see the different layers of my model. And so the inputs to my model is, I believe I have 12 ingredients here, and the model takes the scaled inputs, so ratios of the recipe. We feed this into my model. There's a series of layers, and my model outputs what's called a softmax probability layer. What the softmax layer does is the elements of the softmax output are always guaranteed to add up to 1. And the length of this output is 3 because I have 3 possible categories in my model. I have bread, cake, and cookies. So I know here that the first index corresponds with bread, this one with cake, and this one with cookies. And so what we see here is the percentage that our model thinks that a particular input belongs to one of these classes. So in this case, it thinks there's a 97% chance this is bread, a 2% chance this is cake, and a 1% chance this is cookie. So that's one type of output you could have. I could also, another output type you may be familiar with is sigmoid output. With sigmoid output, which wouldn't really make sense for this problem, each element in this output array would be a value between 0 and 1. So you would use sigmoid when you have a problem where each input can have multiple output classifications. So I wanted to, once I trained a model with TensorFlow, I wanted to use it to see what would happen to settle this cake versus cookie or biscuit debate. So if you're not familiar with a Jaffa cake, it is a dessert that's popular in the UK, and it actually came under contention a few years ago in the early 90s, I believe, because they tax chocolate-covered cake differently than they tax chocolate-covered cookies. And there was some controversy over whether this particular dessert, Jaffa cake, is a cake or a cookie. They call that biscuit, so cake versus biscuit was the debate over there. And so I wanted to see what my model predicted for a Jaffa cake. So I scaled the ingredients down, sent them to my model, and was excited to discover that my model classified this 88% chance of cake. So it agreed with the ruling that this is indeed a cake. If you're interested in the recipe or want to find out more about the history of this debate, I have the links here, and I can share my slides after. So the next step, once I had a model that worked, is I wanted to use AI platform prediction to deploy the model. So I deployed it using the Google Cloud CLI, and I'll show you what that looks like in the Cloud Console in a minute. I'm able to get predictions. It supports auto scaling or manual scaling, which means it'll scale all the way down to 0 when the model is not in use. And then finally, it supports online or batch prediction. So I could send it, one input to get a prediction in near real time, or I could send it a large batch of hundreds or thousands of examples and run a prediction job in the background. This is how I deployed it to AI platform. I use the Google Cloud CLI. There's a couple ways to do it. You can do it in the UI. You can do it programmatically via the API call. I chose to use the Google Cloud CLI to do it. And then this is what it looks like once it's deployed. So don't like to get too far into a talk without a demo. I'm just going to double check the chat real quick to make sure folks can see my screen, and looks like we're good. Okay, so what I'm using here is our hosted Jupyter Notebook solution. So what this does is it lets you create a notebook instance. You can customize the frameworks that come pre-installed in your instance. You can also customize the size of an instance and add GPUs to it. So I already have one here that I have opened in Jupyter, and I'm just gonna run a bit of this. So I have the CSV with all the baking data here, which we can see. And in this section is where I do some pre-processing on the data. So I convert it to cups and separate the label column, which is bread, cake, or cookie, out. And then what we're left with is, let me make this a tad bigger in case you can't see. What we're left with is this data set of ratios. I also need to format the label columns so that they're in that softmax format. So I can't just pass it, the string bread, cake, and cookie. I need to convert it to a 3-element, what's called one hot array, with all 0 values and a single 1 value. So that's what I'm doing here in this cell. And this is, so I do here. This is the code for the TensorFlow model, pretty much the same as what you saw in the slides. I'm not going to run training right now, but you can see the results of the last training run. And this is the code that I would use to deploy it to AI platform. So once I have a model, I can use this TensorFlow model.save method, and I can actually pass it a Google Cloud Storage location directly, and it'll write my assets to this cloud storage bucket. And then here I use gcloud to deploy the model. And then finally, I can get a prediction on this model using the AI platform prediction API. Real quick, let me just show you what the model UI looks like. So in AI platform, a model is a resource that can contain many model versions. The great thing about this is that as a data scientist, ML engineer, I could improve the accuracy of the model, push a new version, set that version as the default, and then the application developers on the front end don't have to change any part of their code that's calling the model. The endpoint will stay the same. If, for example, I want to do some split testing and I want them to split the traffic between 2 different endpoints, then all they would need to do is change the URL of the endpoint, replace the version name here. So we can see that the prediction completed, and what we have here is the softmax probability for the particular input example that I sent it. And in this example, it's saying there's a 46% chance that this is bread, 26% cake, and about 28% cookies. So it's working. This is pretty good, but it could be better because I know that, you know, which index here corresponds with the correct baked good, but it's not necessarily particularly user-friendly for someone that wanted to call this model. They also would have to scale the inputs themselves, which is also not the best. So yeah, we don't want to have folks scaling inputs on the client. So the end users of the model shouldn't have to worry about this. So I was wondering, could we abstract that part? And I use Cloud Functions for this. So Cloud Functions let you respond to different events in your cloud environment through event-driven serverless functions. It supports a number of different runtimes. I use the Python runtime just because that's what I use to build my machine learning model. And there's support for client libraries for calling the AI Platform Prediction API. So in my Cloud function, I wanted to scale the data so that the user could just pass in the values in cups, teaspoons, eggs, etc. Send it to the deployed model and return the highest predicted label. So this is just a rough look at what the function looks like. And if we go back to the code here, I created this function and I deployed it to Google Cloud Functions, which we can see here, this function called predict baking. And I can use Google Cloud CLI to call that function and get a response, and it returns its cookies, which is exciting. So my function is working. I can click into it if I want to see logs or test it out right in the browser. I can see, you know, when it was last called, things like that. I can also test it out here, so I could just paste a JSON of the recipe of the ingredient data and test it out right in the browser to make sure that it's working correctly. So I'm scaling my inputs, and then I wanted to put it all together so that other folks could access the model. So to do this, I used Firebase Hosting. And if you're not familiar with Firebase Hosting, it lets you deploy web and mobile apps to a global CDN using a single command with CLI. If you haven't used it before, it's a really great tool. I use it for my blog as well. SSL is provisioned automatically, and it supports a lot of things like client-side routing, makes it really easy to roll back a deploy, things like that. So I have my website hosted on Firebase Hosting. When somebody enters ingredients into it, it calls Cloud Functions, and then Cloud Functions calls my TensorFlow model, which is deployed on AI Platform, and then the function parses the prediction response and returns it to the web app. So I built, you know, not a very nice looking version of this, and I tweeted it out. And my teammate David East, who works on Firebase, he reached out to me and said, "Can I work on the UI for this?" And I thought, sure, that's very nice of you to offer. So he turned it into this much nicer looking site. And if you want to check it out, where did I put the URL? It's here, whatareyoubaking.com. You can check it out if you want to play with it. So a quick disclaimer if you're going to try it out, which is why I have this slide. People often say that machine learning is garbage in, garbage out, which means that your model is only as good as the data that you use to train it. So if you train your model on not very good data, its output is going to reflect that. So an example of this is, let's say you're building a model on images and you're training it to recognize different cat breeds. So let's say you train your model on lots of data for each cat breed. It's gonna be able to recognize 10 different cat breeds. You deploy your model to production, and it's working really well for cats, but then some users come along and start uploading pictures of their dogs. Now, the model only knows these 10 labels, so it's gonna just try to assign that picture of a dog to a cat breed. And it might even do that with high confidence. So just something you wanna be careful with when you're building a machine learning model or using a model that's deployed. For example, like if you put 10,000 cups of flour into the model, it'll output something and it may not make sense. So just remember that when you're building machine learning models. And so once I had this model, one sec, I'm just gonna double check the chat again, make sure things are looking good. Yes, okay, looks good. Okay, so my thought was, can I use this to create weird desserts? So I inputted I was playing around with the model, testing out random combinations of ingredients, and I wanted to see if we could use it to make weird desserts. So I entered this in, and the model outputted 50% chance of cake, 50% chance of cookie. So I thought, that is pretty interesting. Should I make this? Obviously, I tried to make this. I called it a cakey because it's half cake, half cookie. I held true to all the inputs that I put into my machine learning model. I didn't change any of the ingredient amounts, but I did add some stuff, and I did divide the sugar. So I used half a cup of sugar, but I split that into white sugar, brown sugar. I added vanilla extract and some chocolate chips to make it a little bit more exciting. And it worked. It surprisingly tasted like a hybrid of a cake and a cookie. If you want to try to make it, would love to hear what you think. The recipe is on my blog. So something that I recently added to this model is I wanted to see if I could add model explainability to it. And if you're not familiar with the concept of explainability, as applied to machine learning models, explainability essentially helps you understand why the model predicted what it did. Machine learning models can often be seen as a black box. You don't know exactly how they're making a decision. When my model predicted that something is 100% confident that it's bread, I want to know why it predicted that. Both so that I have more trust in the model output, but also so that I know it's making decisions correctly. And I can use this data to improve the model, to better understand how it's working and to have more trust in it. So we have a service for explainable AI on Google Cloud. You can access it in a few different ways. The way that I'm going to access it is through the newest method via AI Platform Notebooks, which is what I use to build my model. In AI Platform Notebooks, there's an explainable AI SDK that comes pre-installed. And the great thing about that is it lets me explain predictions on local models. So it doesn't require me to deploy my model to the cloud to use it. I can get explanations on a deployed model, but the reason it's great to have it in the notebook is that I can iterate on it, see what explanations look like, use that to improve my model before I even deploy it. You can also use this in AutoML tables if you're familiar with that. So explainability looks a little bit different depending on the type of data that you're working with. So I'm going to show the three most common data types here: image, text, and tabular. So the way that explainability looks, or one way that explainability can look for image models, is it shows you the pixels in the image that cause the model to make a specific prediction. The example here, the image on the left is the original image, and then the two images on the right are two methods of explaining the model's prediction of husky in this case. We're trying to understand why it assigned the label husky to this image. And so what we see are the pixels highlighted that contributed to this prediction. If instead we saw pixels sort of randomly distributed, maybe in the background, then it might be a sign that we didn't have good enough training data. We need to go and add more variety to it. For a sentiment model, a text model, any type of text model, explainability can help you understand which words were most important in the model prediction. So in this case, we have a sentiment model that's predicting the sentiment of this sentence: how could you not love cake? And it looks like it's using the words not and love the most to make this prediction. So in this case, that's a sign that our model is doing a good job using emotive words to predict the sentiment rather than subject words like cake, because the sentiment of this sentence should be the same whether we replace cake with anything else. Finally, tabular models. For tabular models, by that I mean what I inputted into my baking model, any type of data that you might find in a spreadsheet, for example. So like numerical, categorical data. And so for this, you get an attribution value for each feature in your model that indicates whether or not that value pushed your model prediction up or down, and by how much. So in this case, the most important features are the ones with the highest absolute value for their attribution value. So absolute attribution values can be positive or negative. If it's negative, it just means that it pushed the prediction down. This example is a model that's predicting the duration of a bike trip. So I'm going to show a demo of explainability. Again, just double checking here that things look good. Okay. So let's see. So I'm using the Explainable AI SDK here. I have saved my model to this local directory, and I can connect the SDK to it by just passing it the path of that directory. It's going to get some metadata for it, and it's going to write this explanation metadata file to that directory, which the Explainable AI service needs to generate the explanations. I can also, since my model takes a raw array as input, I can also pass it the feature names that I want it to use. So in some cases, your model may accept, JSON keys with the feature names along with the feature values. In this case, I don't. So what's really handy is I can pass in what the feature names are so that the SDK will show me this when it generates explanations. And so I can pass it an example from my model. In this example, it looks like it returned the index 0, which corresponds with bread. It thinks that this particular input I sent it, there's a 77% chance it's bread. And we can see why it thinks that. It looks like flour, the amount of flour was the biggest indicator, followed by water, sourdough starter, and salt only a tiny bit. So that just gives us more insight into how our model's performing, more confidence in, more trust in taking action from the model predictions. And so ideally, I'd want to run this on many more examples to better understand how my model is performing. So with that, I'm going to go back to the slides. So just some notes on things that I have thought about potentially adding to this model. One idea is having more training data and labels. No, I didn't use very many here, so I could have a much better model if I added more data to this. Another thing I could try is AutoML tables, which is one solution that we have on Google Cloud for training models on tabular data, which lets you train models. You upload your data, you press a button to train your model, and it picks the best model architecture for you. And then, oops. AutoML tables does have a minimum number of examples you need. I think it's 1,000. So that's why I haven't tried AutoML tables for this problem yet. I need a lot more data to do that. And then open sourcing the code. I'm hoping to do that soon. Okay, so that pretty much wraps up my presentation. I have one more thing, which is only slightly related to baking and machine learning. I wrote a book with 2 of my teammates, which I have here. Hopefully you can see it. Super exciting, it just arrived last week, called Machine Learning Design Patterns with O'Reilly. You can order it via this link. You can order it directly through O'Reilly. You can also order it on Amazon. And you can follow Lack and myself are both on Twitter. If you want to follow us, hear more updates on the book. We're doing an event with the book, related to the book in 2 weeks, I believe. If you follow me on Twitter, you'll see me promote it. So in the book, we talk about different patterns that relate to all parts of the machine learning workflow. So going from data representation, formatting your data, all the way to training and scalably deploying your model, creating pipelines so that folks can reproduce your workflow. So we cover lots of different aspects of machine learning. It's split into 30 different patterns. And if you're interested in that, definitely order the book. All the proceeds for the book, or all the royalties for the book go directly to Girls Who Code. So it's for a good cause. Would love to hear what you think if you've ordered it or once you start reading it. And with that, here are a few links to learn more about the things that I talked about. And looks like there's a little bit of time before the next session. I'm going to stop sharing. I'm going to go back here. Let's see if there are any questions. That's a common question we got. Camille asked, how does O'Reilly decide which animal to place on each book? I'm going to publish a blog post that goes into this, but the short answer is that it's very mysterious. So we don't have a say in the animal that they choose. They choose it just, yeah, I don't know too much about how they choose it. Ours is called a sun bittern. Could you go back to the link slide? Yes, 1 second. Hold on. Okay, there you go. Feel free to screenshot it. I have a blog post that goes into detail on the baking solution. If you have more ideas about how you could expand this demo, I would love to hear about that. Let me see if there's any more questions. Someone said it's a biscuit. Yeah, in the UK, they're called biscuits. That is the correct term. Any other questions? Oh, I see there's a Q&A section. Okay, I don't see any more questions. Feel free to message me on Twitter. I'm pretty active on there if you have any more questions about anything that I covered. And with that, I will hand it over to Frank. Hey, Frank.
Sarah!
Hey,
I haven't seen you speaking in ages. This is so wonderful to see you.
No, it's been a long time. For those of you watching, Frank and I used to work together on the Firebase team.
We did. And then you went to Cloud and you became a machine learning master. So.
Thanks. I'm excited to see your talk.
As am I, but I'm always excited, I think. So, especially when I'm up on a Saturday morning at 8 a.m. because I'm on the West Coast.
Yeah, I'm impressed. Well, that is very early.
Yeah, and like you might not be able to see, but my eyes are still a bit squinty and I'm drinking lots of coffee.
I have coffee too. Cheers.
I saw some people had some issues loading the talk. So I hope everyone caught your talk, but just so you know, if the interaction at the start of the talk wasn't as much as you expected, then it's not you, it was technical problems.
Okay, cool, good to know, thanks. I think I'm still sharing. I'm gonna stop sharing my screen. And I guess I'll pass it over to you.
Thank you. Guess what I'm gonna do, by the way? I'm gonna live code an app, of course.
I'm shocked. You're a live coding master.
Yes, it takes the least prep, so I like that. I loved your talk, by the way. Thank you so much for doing that. I'm going to kick it off.
Yeah, of course. Looking forward to yours. I don't know how I stopped presenting.
You stopped already.
Oh, I did.
I don't see anything anymore, so I'm going to share my screen in a moment as soon as I hide the bits that show how I was trying to set things up. So let's see where we are. We don't need this one. Okay, hey everyone, give me 1 second to set things up so that you're not looking at yourself, because that's not really all that helpful. And to hide some other things, because I need to share an entire screen with you. Oh, that looks good. That looks good. I think we're getting there. And well, I have 1 minute left for setup, so that's all good. It's wonderful to see so many of you. If I'm looking to the right here, by the way, it's because I'm trying to read the chat there. So I'll try to look mostly at the camera while we're doing this. I'm Frank, or Puff, whatever somebody introduces me as. I'm a Firebase engineer at Google. I've been that for 5.5 years now, something like that. And in doing that, I explain a lot of technology to a lot of developers. And I love that. I always love doing talks like this. Sorry, the backstage chat is going crazy for me now. I'm probably going to close that so that I'm not looking at myself anymore. Give me 1 moment so that I actually can see what's going on, because I would like to actually know how things are looking for you all. We'll see. I guess I'm not going to be seeing how it looks for you all, in which case I hope to see the questions later. Okay, what are we going to do today? We're going to be building an app. Actually, we're going to be building 2 apps, and it's probably easiest to show you what we're going to be building. Let's see. I'm going to share my entire, not my desktop, that doesn't help. Uh-oh. There we are, entire screen. Okay, now I hope you can see my screen. Yes, cool. That's looking good. In which case I'm gonna minimize all of you so that you can see this thing. Give me one moment. There we are. I was having an echo. I'm not going to switch to presenter mode because honestly, there's not a lot to see here. But we're going to be building an app. And as I said, I'm Frank or Puff. We're going to be building this app using Firebase. That's because I work on Firebase, but also because honestly, it's the easiest way to live code apps. And we're going to be building 2 apps. So we're in a bit of a rush because I think I have about 45 minutes and I have about an hour of content as usual. So let's see. We're going to be building 2 apps and they are the first one is a social, local, mobile, crowdsourced weather application. If Sarah is still here, she knows this one very well. It sounds very complex. It's actually the simplest app we can build. Because remember back in the day when we could travel? Well, I definitely remember. I used to love travel. But one thing I always notice when I travel is that I wonder what the weather is like back home. And the weather back home for me is San Francisco. And if you've ever been to San Francisco, you know that we have 2 types of weather. It can either be sunny or it can be foggy. We have nothing else. And right now it's relatively sunny. It's not too bad. So what I would like is to have an app where if my wife wakes up in the morning, she can look outside and she can click whether it's sunny or foggy. And then, right, if I open the same app, I can see what she clicked so that I know what the weather is like. Right? It always gives me a feel of being back home. Well, can't be too hard, right? So we're going to be live coding this. Now, I don't expect anyone to code along, but if you record this, you will be able to replay it and build the same app. So let me see. I really wish I could see the chat somewhere. Let me see. What are we going to use? So I'm not going to use any IDE. Essentially, all I'm going to use is browsers. So I'm going to go to StackBlitz first. And StackBlitz is an online IDE. It's pretty much Visual Studio Code in a browser with all kinds of extra tools around it. And we're going to be building a web app in that case. Now, Firebase works on many platforms, but I'm going to be building a web app just because it's the easiest to show. And I'm going to start with a blank project with JavaScript. I could have used any of these technologies. Well, some of them I might not know very well, but I could have used many of them. But we're going to start with plain JavaScript just to show you that this works everywhere. Okay, so we're going to create a new project. And now this is an entire IDE in my browser, as I said. And if this looks familiar to you, that's not surprising because they actually run Visual Studio Code in the browser here at StackBlitz. And that's really cool. You can see that we have 3 panes here. So on the leftmost, you see the list of files. And I opened 2 of the files, which is pretty much the most important thing we need. So I'm going to close that pane so that we can see a bit more. I'm going to zoom in so that we have a bigger font. Ooh, that's a bit much. I hope this is readable for everyone. In a moment, I'm actually going to drag things to the side and we'll see a bit more. And one of the wonderful things about StackBlitz and these types of tools is that everything you see is live. And that means that if I, for example, type hello here, you can see that it shows up in the panel on the right straight away. So we have a file here and we have the output of that file on the right. That's pretty cool. Except that I'm not building a hello world. I'm not building a starter app. I'm building a social, local, mobile, crowdsourced weather application. So let's get rid of this. Yeah. Let's get rid of the code. We're going to get rid of this. Also, one thing, I love the hot reloading that StackBlitz does, but it's a bit too hot reload for me. So I'm actually going to do a page reload and do it only when I save the file. You don't have to, but for me, this makes it a bit more that I have control of when you see an error message, essentially, pretty much. Okay, let's see. Remember what the screenshot looked like? So first we need to figure out actually sorry, There we are. So first, we're going to make that HTML. So what we need for that is, remember, we saw a label at the top. Oh. And right now, what did I say? It's sunny. It's actually getting sunnier by the minute here. Let's do that. Then we're going to do a break. Especially if we make it a tag, it will actually do something. And then we're going to do 2 buttons, right? One button is going to be sunny. And the other one is going to be foggy. And you can see that autocomplete works, which is one of the wonderful things. I promise to not do any snippets today, but I will definitely rely on autocomplete. And I actually am going to copy paste 1 or 2 things. But I'll copy paste them from something you can also see. OK, now this the screenshot we saw, which is not too surprising because that's where I took the screenshot from. So let's switch to the JavaScript and actually make this work so that the buttons do something. So I'm still trying to do some relayouting on my second screen so that I can see what questions we have coming in. There we go. Let's see. I'm going to get the buttons from the HTML. We use query selector all for that, and it's all the button elements. I'm going to make the side panel a bit smaller so that I can actually see my HTML a bit better. OK, now we're going to loop over those buttons, which gives us a button. And OK, on the button, we're going to add an event listener. We're going to listen for what event? For the click event. So this code gets executed whenever I click on a button. And when that happens, let me actually also get the label from the document. So documented query selector. In this case, there's only 1 label. So I'm going to do this. Then we're going to set label.inner text equals what do we do? Target. So that's the button that we clicked on, and then we're going to do its text content. No. OK. Let's see what we get now when we click the foggy button. Nice, 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 nice. Yes, you can get a shareable URL. I see that the chat is about that. Somebody's asking if I can share this, and yes, I can. I actually think I can even, but I need to zoom out a bit. Let me make this URL slightly easier. What did I say? Whether DevFest? How does that sound? Okay. Now, I don't think I can paste this in the chat, but if you go to stackblitz.com/weatherdevfest, or if you go to this URL, you can follow along. Right now, it won't be doing a lot, but so weatherdevfest.stackblitz.io is where we're showing this now. Okay. Back to the code. So this is pretty neat, right? It's like it's basic HTML and JavaScript. We're changing the value. The problem is that if I give this to my wife, who's having breakfast right now, and yeah, she can click the button, but I won't see the result. So that doesn't help all that much yet. So let's see what we can do to fix that, which involves adding Firebase. So I'm going to switch back to the slides for a moment and tell you a brief bit about Firebase, but we're going to race through it. So Firebase is a set of online services. Wow, there's lots of speaker notes here. Ignore them. They came from a template that I used. It's a set of online services that you can use to build apps, both native mobile apps for iOS, Android, but also web apps like we're doing today. And the set of services varies a bit what you use. You can also use it for games, for IoT, for many things. So this is the set of services. But I promised you live coding. I'm not going to talk about all 18 services. Actually, 19 it is now. We're going to focus on the ones on the left here, which allow you to build an app. And that's actually what Firebase started with 7 years ago, 8 years ago. Right? It's a set of backend services. And you speak to these services from within your application. So what we're going to be doing is we're going to be writing code, JavaScript code, that talks directly to these features. In fact, let's see. We're going to be using specifically these 2 products today. So both of these are databases and both are part of Firebase. And we're going to be using both of them just because I like showing you more than one thing. But we're going to start with a real-time database. It's the original Firebase product. And the real-time database is very, very specific in that it changes this model. So you've probably seen this one before. It's a 3-tiered model, right, where you have a bunch of devices, whether it's web or mobile, doesn't really matter, that talk to a server, right, where you write code and then your code talks to the database. With Firebase, that's not how it works. With Firebase, we actually remove the server from the equation mostly. So your devices are talking directly to the database, which leads to all kinds of interesting considerations. The first one is like, yay, no more needing to write server-side code. We can do everything in templates today. But the other part is, how do we secure that? And we'll have a look at both. Now, Firebase uses a JSON database, and that's essentially just a hierarchy, right? It's a nested hierarchy of values. And you can store values in the database, like here, a list of grocery items, and then you can display them on your device in your app. The key thing that's interesting about Firebase is that it's reactive. So in most databases, if you read something from the database, right, you do a get type operation and you get the data from the database and that's it. With Firebase, that's not the case. With our real-time database, we keep an open connection between the server and the client. And in this case, we're using on. This is JavaScript code that we'll write in a moment. And we'll keep listening for that value. So if something changes on the database, we'll get informed straight away. And this leads to Firebase's unique selling point, which is that we make it, well, not trivial, but we make it very simple to build multi-user collaborative applications. And here in this example, you see that one yellow line comes from one device, makes a change to the data, and that the change is synchronized out to all other users within milliseconds. That's the original Firebase promise, and that's the one that we're going to be using today. Okay, this is the database that we're going to be using today. But instead of looking in a slide, let's actually go to the Firebase console. So this is the Firebase console. This is where you see all of your Firebase projects. I have quite a few, but we're going to open Weather SF here for the moment. Okay. Now on the left here, I see all the Firebase products. I zoomed in a bit because normally you would definitely see more than, yeah, you would see labels for the products. Thank goodness. I have a hard time recognizing these icons. Okay, so we're going to go to the real-time database here. We could use other products, but we're only using this one. And this is actually what we're going to be building. So we're going to be adding a node called weather to the database. And in that node, we're going to write sunny or foggy. Now I'm going to delete this because it's no fun if it already says that it's sunny outside. So I'm going to delete this data. But this is the database that we're going to be using in our app. Okay, we're going to go back to templates. We're going to write the code. So we're going to add Firebase to our project. We do that by in the dependencies adding the Firebase package. This pulls in the NPM module for Firebase and allows us to use it in our code. So that's the next step that we need to do. We need to import Firebase into our code. I'm actually not sure if I use the CSS, but I'm going to leave it. I'm going to say import Firebase from Firebase. That's the starting point. So this gives us access to the SDKs. Next up, we need to initialize Firebase. We do that by saying Firebase initialize app. Now we need to pass it some configuration data. And in this case, we're going to pass it the database URL of the database that we are accessing. And let me actually move the console here. That's this database URL minus the weather bit, actually. Actually, let me go back up to just the entire database. So I'm going to copy this URL in here. Have the right spelling? Yes, I do. Okay. Now this gives us access to the database. It's taking a while to compile, by the way, because Stacklist is right now pulling down or trying to pull down the package, and I need to click one button here. That's a recent change they did. Okay, that's pretty cool. So next up, when we click one of the buttons, we need to, instead of setting the label, we need to write to the database, right? So I'm going to leave this, and because we'll need it in a moment, but we are going to write to the database. To do that, we need actually a reference to the database. Sorry, so let me set up a reference to the database. And the reference to the database is essentially a pointer to that same location in the cloud that we have here. So we're going to point to this node. So that's firebase.database.ref. And we're going to ref weather here. Spelling matters. So this is a pointer to the database. And keep in mind, if you have the same page open, you're pointing to the same location in the cloud. So we're all going to be writing and reading the same value. And that's how we share it. Okay. Now we're going to do ref.set. And then we're going to do, remember, we get the button that was clicked. Actually, I promised you I would copy paste one or two things. Let's copy paste this one. That. Okay. Now this gets more fun if I am able to show you a bit more. So I'm going to split this off into two windows. Like, let's do it like this for now. I see there's already a value. People are clicking the button already. If I click this button now, you see that the value changes in the database and it highlights in yellow straight away. If you actually have the same URL open, the whether devfest.stacklist.io, or whatever the URL I said here, stacklist.io, yes. You can also click the button and it will also be able to change it. What do I want to show you here? Right. I will actually show you a few more things. Fun. Okay. I'm going to make this a bit smaller. Yes, this still fits. Perfect. Like that. Perfect. That all fits. We're making this one a bit smaller. Yes, we can do this. Somehow my HTML file closed. Let's see if we do this. Thank you for changing the values for me. Now, what happens if we say, right, if we get a malicious user who says, I was watching a video game documentary last night, who wants to say Pac-Man, right? And keep in mind, I type Pac-Man, you could be typing something else. Now, what happens if we click here? You can see that nothing is written to the database, but if I click Foggy, it does write. So something magical is happening here that allows it to, that means that I can only write Sunny and Foggy to the database. That's because, remember, your JavaScript code is talking directly to the database. We need to secure that in some way. And since we don't have a server, we can't write server-side code. But what we can do is write server-side security rules that we see here. Making this a bit bigger. So these are the security rules. It's a custom language, proprietary language. It's JSON here, by the way. As you can see, that says that we have rules. And we have a node called weather. And anyone can read and write that node. That's clear. But we validate that you can only write the new data if it's a string, and if it's sunny or foggy. It's the only values you can write. So this is the amount of damage you can do. You can write a lot, but you can only write sunny or foggy. This is how I secure the database, and this is why I have no problem sharing it with you, because there's not a lot you can do wrong. So okay, I'm going to remove Pac-Man from here. We're back to the original, because we still need to show the current value, right? If I click foggy here, it still shows sunny. I'm actually going to change this first and say loading, so that we know that it's actually a hard-coded value. Now, you saw on the slide that we did ref.on. And ref.on attaches a listener to a value in the database. So we're going to say value. We get a snapshot of that value. And this is an asynchronous operation, so we need a callback here. Now, it may take a moment to get the initial value, but once we do, we want to set it to label.innerText. We're going to do snapshot.val. And with that, I don't need this commented line anymore because we reuse all the parts from it. So now when I hit save, look at the top right to see what happens. Okay, here we go. Save. Did you see it briefly flash? I'll reload. Loading, sunny. Loading, sunny. We click foggy, it changes in the database and clicks at the top. Note that I don't change the label here anymore, right? All I do is listen to the database and use that. So we're doing a little loop, right? When I click the button, it writes to the database. And since I'm also listening to the database, it updates the label. And I can see that we have a lot of debate going on about the weather in San Francisco right now. Okay, that's the first app we were going to build, a social, local, mobile, crowdsourced weather application. Honestly, since it's only SF, it's actually quite global. I'm going to switch back to the slides to tell you a bit more about what we're doing. Because we've coded this. Lots more about Firebase, but I actually need to watch the time a bit. So you know what? I think we won this one. Check. We're going to build one more app, and you can see it already because I'm showing you the outline. We're going to build another chat app. Google loves building chat apps, you know that. So we are going to build our own, pretty much the world's, I won't say ugliest, but definitely one of the smallest chat apps you can build, because we have like 25 minutes left. So we definitely need to rush it a bit. Okay, we're going to build a chat app where we are going to, show you this pretty much. Okay, as I said, let's code. I love code. Let's. Okay, we're going to create a new project for this. Here we go. Now, I remember people were asking, so let's do DevFest chat. I hope nobody has that name yet, because, oh, you know what? Nano chat DevFest. I often call this one Nano chat. Let's do that. My project is renamed, and here we go again. I'm gonna once again change the settings to page reload. By the way, this also has partially to do with how Firebase is initialized, but definitely the page reload trigger that we have here. Okay, that's it. And I'm gonna open my JS again and my index.html again. And we're building a chat app, remember? So let's get rid of this JavaScript and this HTML. What does a minimal chat app look like? Let me quickly sneak a peek at my other file. Got it. So we're going to have a list of messages at the top, right? So we're going to have an ordered list. That's how I like doing it now. Like this. And in there, we're going to show the messages, right? So you're going to see something like that, right? But I'm not going to hard code. Well, maybe I am actually going to hard code. But in that case, let's say that we're loading the messages, which we're not doing yet, but we'll get to that. Okay. Now, the chat app wasn't all that interesting, but it did have a form, if I saw correctly. And in there, I had an input, right, where I could input the text. And then I had a button, a submit button specifically. Then we have the end of the form. How does this look for the Nano chat web app? It's not too bad, right? Okay, let me see. I think we're ready to start writing some code for this, because I don't think we need all that much more. Timing-wise, let's actually straight away look at how we're going to wire this up with Firebase. Because I'll be honest, a chat app without Firebase is not all that interesting, right? Without a database story behind it. Okay, so remember, I said Firebase has two databases. So the real-time database is our original database and is a JSON database. It's a tree of values. That's how you can most easily see it. And we stored a single value in it. We could definitely build a chat app in there. Done that hundreds of times. It scales totally fine for that. But we're going to be using Cloud Firestore for this. Honestly, mostly because I want to show you that that option exists. And Cloud Firestore is another database that we created later that focuses more on read scalability and on a data model that we think fits better for some people. So Cloud Firestore is a cloud database that stores data in documents and collections. Sorry, I had to think for a moment there. It's fully offline. It supports same real-time syncing as real-time database. That's why that animation looks so familiar. It supports working offline, which real-time database also does, but Firestore definitely has a better model for that. But mostly, Firestore is more scalable when it comes to read operations. So if you expect to have like hundreds of thousands of users all looking at the same data, Cloud Firestore is your better option. Although real-time database can also do that, but then you have to care about how you scale the data. So you're a bit more involved in it. That is because Cloud Firestore actually puts the data in multiple data centers automatically. So the API doesn't show that, but it's replicated across multiple data centers. And it's, I think, earthquake-proof or Godzilla-proof, one of these. But like, it's data centers that are far enough apart that an earthquake won't hit all of them at the same time. And as I said, it's a document database. So you store like the data in a document. The document is a bunch of fields that have a value. Each document is part of a collection, and each document can also have sub-collections. So you can nest your data that way. We're not going to do that today. We're going to use a single collection. Okay. You can put queries on the database, and we're going to use a tiny bit of that, and you can then get that data. honestly, let's just write some code. That feels like a way better idea here. Let's go back to the JavaScript code. No, let's actually first look at the database. Here we are. So I'm going to go back to my list of projects, and I'm going to open my NanoChat project. Now, in here, you see that we have all the Firebase services that we can manage, by the way. So we have many more, but I'm going to stick to the top and click Cloud Firestore, which gives me, again, a view of that database. And you see that we have a chat collection already, which is where I got the screenshot from. And lots of people are saying hello. We'll see why that is in a moment. But I'm going to actually delete this collection for now, just because it's easier if we start without something. Okay, here we go. And we're going to wire this up in our code. So remember what we did last time. We added a dependency for Firebase here. So this just adds it to the pretty much the package.json. Okay, we're going to go to the JavaScript code. And we're going to import Firebase from, that's a very consistent typo today, from Firebase. Okay. See, with that, we're ready to go. Now we need to do our configuration. Honestly, for Firestore, well, excuse me, I should have muted. For Firestore, the configuration is slightly different and more complex than for the real-time database. So I'm going to copy-paste it from the Firebase console. If you have a Firebase project, you have the same, by the way. So I'm going to go to my project settings, I think. No, where is it? Let me actually do this, because then I can go to the project overview. That's what I wanted. And I have a single app because I created a web application already. If you click Add App here, you can add your iOS, Android, and web applications. You need to add those because Firebase needs to know something about them, right? It needs to know that the app what app is connecting. So I'm going to go to the configuration for this. I'm scrolling down and I'm going to pick the config here. This gives me a bunch of configuration data. I'm going to copy this and move it over into my code. Now this is configuration data. It might be called API key, but that's just because somebody gave it the wrong name when we were building the product. This is actually called an API key, but it's not a secret. I will gladly leave it here. You can copy and paste it. There's no damage you can do to my project. Here you see the database URL that I typed earlier. I am actually going to clean this up a bit because I don't think we need all of it, and I'd like to keep my code just small. But all of these have meaning, and they allow my code to find my Firebase project on the server. So I think these are the ones I need right now. I might not even need all of these, but let's see if this works. If it doesn't, I'll put all of them back. Okay. So remember, we do firebase.initialize app with this Firebase config that we have here. That initializes Firebase. So now, again, my code can find the project on the server. Remember when we were doing, need to install the package here. Remember when we were doing the real-time database, we had to create a reference to where we were going to write and read in the cloud. We're going to do the same here. We're going to create a ref, and the ref is going to be firebase.firestore. So earlier we had database, now we do Firestore. And then it's called a collection, and the collection was called chat. We create a reference to the chat collection in the cloud. Let's see. Let's first write the messages. So documents, sorry, add event listener. We're gonna, not document, we can't listen to an entire document. Query selector, let's do that first. We're gonna get the form from the HTML, and then we're gonna add an event listener. We're gonna add an event listener for the submit event on the form. So this gets called when you hit the submit button or hit enter. It's really nice to not listen to the button, but to the form here. If that happens, we get an event just like before, and we respond to that. Sorry for not making it fit. Now, let's first actually alert our message for now. We do E, no, not E, we can't do that. We need to actually get the input. Let's actually get a reference to the input. So document.query selector input. And since this is the first input that we have in our form or in our HTML, that gets me the right input. Then we're going to do input.value. Okay. Now if I type something, hello, and I hit enter, I get an alert that says hello. And my page reloads. Bonus points if you know why that is. Since I submit the form, right, it's trying to send data to the server. But we're going to take control of that sending in our own code. So we want the browser to not do its default behavior. We do that by saying e.preventDefault, which tells the browser to not do its default behavior. Somehow I always end with return false also. Well, let's try this again. Nice, now it shows an hello and it doesn't reload. One thing I really prefer is to also actually clear out my input when I've done this, so that I know that the value has been like handled. Hello again, shows it, I hit enter, and my value disappears. That's nifty. Now let's write the Firebase code. So we have the database reference. So we're going to add a document to that. And that document has two values. So documents in Firestore are not ordered by default. So I need two things. I need the message that we typed, which is input.value. And I'm going to store that in a field called message. Then I need a timestamp, which is just a way to know when the message was sent. Now I'm using date.now, which is the local timestamp in my browser. Honestly, it's probably better if we let the server calculate this, but this is slightly easier code to write. Okay, so I'm going to do that, and we're going to wait for that to complete with a then. So, right, this can take some time, so we're waiting for it to complete, and then we're going to clear the input box. Okay, let's see what happens now. Hello. Enter. You saw that it disappeared. It took a brief moment. You probably didn't notice that. It doesn't show yet because we're not loading. But if we now go back to Cloud Firestore over here, you will see that we have a chat collection and we have hello in here. And that's pretty cool, right? Like we're writing to the database again. Just like before, I'm going to pull this out so that we can see the database and the messages side by side. Oh, I didn't realize I hadn't closed the other one, but okay. I need to make this slightly smaller. Sorry, the size was for the fact that I can't get my layout to fit correctly. Let's do it like this. It really needs to be a tiny chat application here. Okay, so we still need to pick up the messages from the database. And just like with the real-time database, we're gonna like attach a listener here. Remember, Firestore also does real-time listening. So hold on, did I call it ref? Yep. Now, in Firestore, this is called ref.onSnapshot. Just because on was a bit short. And onSnapshot because we get a snapshot of the data in the database. In this case, it's called a query snapshot. That's what we get here. Naming doesn't really matter, but I like to stick to what the documentation uses. This is a query snapshot of all chat messages. Now, that might be a bit much, right? So what I actually want to do is I want to, let's say, show the last, how big is the screen? Like that. That's the last 5 chat messages. So to do that, we're going to order the data by its timestamp, the field that we entered. We're going to do that descending. Oh, let's do descending like that. Then we're going to limit it to only 5 messages. See? So we're ordering it first by descending timestamp so that the newest are at the top. And then we're going to limit it to only 5. Okay, so this gives me the latest 5 messages. That reformatting was Stacklist doing that. Okay, now let me get my list from my HTML. Query selector. I wish that method name was a bit shorter, by the way. Darn. I can't get it to fit, people. You know what? In that case, I'm going to move this to the top so that I'm not constantly looking at it like that. Also makes it fit because fewer tabs. Here we go. And so we get a snapshot of 5 messages. Even if only 1 message was changed, we'll still get the snapshot with the 5 messages. Only 1 of them will have been loaded from the server. But this means that I'm first going to actually clear out the existing messages that I have, which also gets rid of the loading marker the first time we do this. Now we get the query snapshot. we're going to loop over what's in there with for each. That gives us a document. And that's a document snapshot of the data we see on the left here. For each document, we're going to create a li element that goes into the list. So that's document. Now keep in mind, I have two documents here. Doc is the document from the database. Document is the HTML document. It's a bit confusing at times. That's why we always call the Firestore one doc, by the way. Okay, so we got an li, and now we need to set the content in there. So we're going to do text content equals, and we do doc, which is the snapshot from the database, .data, and then the field is called message. Make sense? Okay. Then we're going to do, let's see, list.append list item. Okay, I'm going to hit save in a moment. I actually see that there's a button now, which means that you can see that I click it. So let's see what happens if we do that. Ooh, my list didn't load. What did I do wrong? Yeah, it's not called list, it's called OL. That's my mistake. Okay, let's try this again. Hitting save and see what happens now. Ooh, and there's my single chat message. Now remember, if you go to nanochat.devfest.stackblitz.io, the URL that we have at the top right here, you can also type messages. You might be doing that already and wondering why they're not making it into the database, where clearly, right, this puff guy can say hello all he wants and somehow it shows up. The reason for that is, as you might guess, security rules, right? I definitely would not show a chat app like this on a live stream like this if I hadn't made sure that it's going to be a civil chat. In fact, it's going to be a bit boring chat because I think I can say hello again. No, I can't say hello again. Did you see what happened there, by the way? I hit enter and briefly it showed and then it disappeared. But if you actually have the same screen open, it won't show on your screen. When I add a document to the database, I'm going to make the code slightly bigger again. Here, when I call this add, actually our local on snapshot gets called with a new document straight away before it's even sent to the server. That's what we see briefly. Now, then the server checks the message. And in our case, the server rejects the message. I'll show you why it does that in a moment. The important thing is the server tells the client, it's like, nope, that's not a good message, which means two things. You will never see this message, even though when I hit submit, I briefly see it. It also means that now my client needs to fix its problem, right? So we essentially get called again with a query snapshot without the message that I'm trying to submit. And this is a very common behavior in Firebase. If you see, hey, my data briefly shows up and it then disappears, it's almost always security rules rejecting the write operation. You also see that my input is not cleared when this happens because I only set it to empty in the then. The then only fires if the server allowed the message. In fact, if we put a catch in here, we would actually get an error message saying permission denied. Okay, so we can't say hello again. Hello developers, maybe. Also not hello developer. Oh, I have no idea what I allowed. Let's try hello everyone, not everyone, that's for sure. Oh, that is allowed, good. You saw the message show up here. Now, instead of me guessing, let's actually look at what happens here, how we validate this. So we have security rules for Firestore, and as you can see, it's a different language. It's not JSON anymore, but it's a similar logic. So there's like some preamble that's the same for everything, and essentially says we're securing the documents for this database. But here you see that we are writing a rule for our chat collection. Everyone can read it, but you can only write it if the message that you're posting matches and then a long regular expression. Now, apparently I have a list of words here, and this is what's allowed. I can have hello, which we know, and white space, and then any of these words. Ooh. I thought I had Firebase already. Yeah, Firebase is in here twice. Let me change my security rules. Let's remove the second Firebase. But then instead of that, let's do, we're at the DevFest. So let's do hello DevFest now. You see that it gets rejected, right? So if I now go to my security rules, let's see, what did I allow? Summit, virtual, meetup. Meetup. I'm going to put it there. I'm trying to keep an order so they know what I'm doing. It's all lowercase, but it allows all casing. So I'm going to allow DevFest here. I'm going to publish these rules. These rules are live immediately. Well, it says it can take up to a minute, but I can type them here and they will be live very quickly. Let's see if it already works. And look at that. Now I can say hello DevFest. So I'm actually actively working on securing the application. What you also see, by the way, is that when we add a new message, that the latest message disappears. Because we had an order by timestamp limit 5, we get only 5. So when we add a new, I only have 5 fingers, I should have done a lower number. If I add a new message at the top, the lowest one disappears, right? And then if we add another one, like this one disappears. Does that make sense? I hope so. I can't see whether it makes sense. Okay. So we've built a chat app, and like how many lines of code was it? 42. Honestly, it could probably be a bit shorter. But that's pretty short, right? This way I can secure chat. There's, by the way, many other ways to secure it. You definitely wouldn't secure a real chat application with a single regular expression. You would probably do something with either machine learning, as Sarah was showing, right? For like, is this a polite chat? I know Google Cloud has a great service to do sentiment analysis on chat, and we've used that to actually build like a very friendly chat, as we called it, where we validated that the messages were friendly. Or you would do something with your own code that runs when you write something to the database. You'd essentially run like a message validator here, right? And you could do that either correctively, right? You first show the messages to everyone, but then remove the ones that are like not polite. In which case, people might briefly see an impolite message, but it gets cleaned up quickly. Or you could do it by having a queue of pending messages. That's an alternative way of doing this. Okay, that was the second app. I said, let's code, and we definitely wrote a lot of code because we built that web application, which I think means that we've delivered on our promise of building 2 complete applications in 45 minutes. Let's see. So we use Cloud Firestore here. Cloud Firestore, if your application is more read-heavy, bigger documents, not that many writes. That's typically the logic. If you have many smaller writes, real-time database. Both can scale infinitely. The difference is that Cloud Firestore does more of the scaling automatically for you. Where with real-time database, if you need more users, you might need to do some thinking yourself about what's known as sharding and scale-out behavior. All stuff that we can help with. Second database. The next step that I would have added is Firebase authentication, which does serverless authentication. So in the client, we would have written a tiny bit of code, and then the user would be signed in, which would, for example, allow us to then start only allowing messages by signed-in users, but also start blocking those users. Or maybe you could edit your message after you've typed it, but only your own message. Cloud storage is a fun product because we could have added images here, right? And hosting is great, actually. You know what? Let's show hosting. I have 1 minute left. I'm going to go here because let me make this tiny bit smaller. Yes, now we can show. Because there's a Firebase icon here in StackBlitz on the left. Because StackBlitz is integrated with Firebase. I'm signed into Firebase already in StackBlitz, but you can see here is a list of all my projects. Now I have a project called NanoChat because that's the one we've been working. Firebase has the hosting product also. So if I click here, I can now deploy this mini web application to Firebase Hosting. So click this. It's bundling up. It's making everything into a single web app. That takes a moment. And now I can open the live site. Now, this number is not important. I'm actually going to show you the correct URL. So, make it a bit bigger. I had a hard time finding the plus button. Okay. And in fact, you can also use .web.app. So nanochat.web.app is a Firebase hosted website. Now this is the exact same app with the exact same data, but now it's on a URL that you will typically share with people, right? Because this can be a URL like this that you get by default, because that's my project name in there. But I can also, let's say that devfestnanochat.com is still available. I can register a domain and use that for my chat application. Okay, that's Firebase hosting. We could use Cloud Function, as I said that before. You could listen to the messages being written. Cloud Functions does that precisely. Sarah talked a bit about them, but Cloud Functions are small snippets of code that run on the server and that can run in response to events that happen in your database. So if a document is written to Firestore, you can look at the document and see if it's correct and either then approve it, like move it from the moderation queue to the final version, or you can reject it. And of course, there's much more. Some of these products work on web, others work only on native mobile. Okay, so with that, we've built 2 complete applications in 45-ish minutes. If you'd like to learn more, not sure. This URL probably still works. Firebase.live it's a redirect to a website. But we have a code lab there that is getting started with Firebase on the web. And that essentially talks you through building something like this chat app. It's a guest book for a meetup page. And if you'd like to learn more, go to firebase.google.com. And if you like to reach out to me, tell me what mistakes I made in my talk or anything else, twitter.com/puff. If you have any questions about Firebase, firebase.google.com/support is your go-to. But Stack Overflow is also never the wrong spot to ask questions. I answer a lot of questions there. With that, I'm going to hand it back to the organizers. I want to thank you very much for being here today and for joining me for this fun live coding experience. Oh. I'm going to do some questions, I see. Thank you, Linda, for telling me that. I'm so used to a host picking over. Now I need to find the Q&A tab. That might take me a moment. Can somebody help me? I'm literally trying to find it next to backstage. Of course I don't see this. Why would I? Sorry, folks. The platform is new to me, so I'm trying to figure it out. I really don't see a Q&A. Thank you, Corinna, for giving me the questions. Okay. Dhruv asks, does Stack Plus support Python or only Node and JavaScript? I actually think it's only JavaScript-based languages. They do have a subscription where they also allow server-side, but I think that is also only Node. I'm not 100% sure, though. There's definitely other tools where you can do similar things, by the way. I just use StackBlitz because they have the nice integration with Firebase Hosting. But a Glitch, for example, also has such an integration and would work with any language you want because you're just essentially running a virtual machine there. I swear, people, I don't see I don't see a Q&A. I wish I did, but I'm checking all the tabs I have open, but I don't see a Q&A tab. I'm gonna keep looking, but also keep answering some questions. And thanks, organizers, for helping me through this. Rebecca asked, is it okay to ask for your Firebase slide deck? Unfortunately, Rebecca, I'm not allowed to share that. I would need legal approval and like lots of things that I'm not a fan of. If you want to know specific things, I can totally share that with you. I can't share the exact deck, though. I'm sorry about that. Patrick asked, what's the purpose of return false at the end of the event listener? It's a good question, Patrick. I'm never 100% sure. I just probably one time it didn't work and I kept doing it. But the reason is that that it stops the event from bubbling up further. So the calling event.prevent default means that the browser knows that the form submit shouldn't happen. Return false means that it the event doesn't bubble up to higher things. So if I would have an event handler also on the form, or not on the form, on the HTML body, for example, it doesn't get called anymore. I hope that makes sense. Vasuja, I hope I pronounced that correctly. Vasuja Singh is asking, can we add our own regular expressions to the rules? And yes, you definitely can do that. If you create your own Firebase project, you'll have full control over the rules. The Firebase console, of course, was not accessible to anyone but me. You can add more people to a project, collaborators, but you would normally, of course, not add your end users to that project, because then they could change your security rules. That's actually a key thing about how we secure Firebase, right? We make a clear distinction between collaborators and other users. And even if they sign in with Firebase authentication, they won't be collaborators. Another question from Rebecca. What's the difference between Firestore and First Database, which was real-time database? Honestly, we get this one a lot, and I wish we had a better answer. The billing model, we're between friends here. The billing model is very, very different. So always look at that. But it's the data storage model. So the First Database stores a tree of values, and you can do in that tree whatever you want. But that also means that you must figure out your entire own data model. So yes, it's great because it's as flexible as it can be. And yes, it's harder because you need to think up everything. Firestore uses documents and collections. So I created a chat collection. And in that chat collection, it made total sense that each chat message was a document for me. Your use case might be different, but for me, that made sense. So it helps you a bit more in what the data model is. Aside from that, what we did with Firestore, it was the second database we built. We kept the good things of the real-time database, like its real-time synchronization and its direct access from the client. But then we focused a lot on read scalability. So real-time database, if we would have a chat app and we use it for years, we might reach like 100,000 chat messages. And at that point, querying it becomes, well, 100,000 would probably be fine, but let's say that we get to 1 million. Querying a node that has 1 million children under it becomes a performance concern on the real-time database. So on Firestore, it does not. On Firestore, no matter if you have 1,000 chat messages, 1 million chat messages, or 1 billion chat messages, the performance will be flat. In fact, we were reading 5 messages, and let's say, for sake of argument, that took 1 second. Like, I don't really know how long it took. The thing is, if it takes 1 second, now that we have maybe like 50 chat messages between us, it will take 1 second with 50 chat messages, with 1,000 chat messages, with 1 million chat messages, with 1 billion chat messages. It will only take that 1 second. So Firestore's read performance depends on the amount of data you retrieve, not on the amount of data it queries. This is very unique amongst databases. Right? Most databases at best have a, like, I'm not sure if you know big O notation, but like it's the performance, and log n or n log n are the most common ones. Firestore does not. Firestore has flat performance, which also means that once you're done building, right, you run like your first test and you insert like maybe 1,000 messages. That's the performance you're going to get in production, no matter how many messages you add to that collection. What I find is with Firestore, I can do develop, deploy, done, right? I'm done as soon as I deploy because I know what my performance is going to be. With real-time database, you will have to take more care of that. Everything is a trade-off though, because with real-time database, write performance is a lot better. Remember, Firestore has to spread data amongst multiple data centers. Real-time database does not do that. It actually does, but it doesn't do it real-time. It does it as a like separate operation, which means that the availability of the database is lower, but the performance, write performance is a lot higher. So I use real-time database mostly, I'll admit, but could also be because that's historical. Okay, let's see. We have a few more questions. One more. Ahmed is asking, should I master Python first? Ahmed, it's hard for me to say that one. I can't answer what you should do first. My wife recently was doing some programming courses though, and she had done some JavaScript before, was recently doing Python and loved Python, but she also liked JavaScript, right? I'm a polyglot. I love programming languages. I love a lot of them. So, and Python is a great one to get started with for sure also. Okay, let me see if we have any other questions. in the chat. I'm quickly checking what the agenda says, by the way. Like, what are we doing next? I think we have a break next, is my guess. Yes, we have a break. I see the agenda now. Found it. Okay. We have a break if there's no more questions, by the way, that's totally fine, because that means that, as Googlers often tell each other, we get 4 minutes back in our day. And that means that I can grab some more coffee, because it's still before 9 a.m. Oh, I see that we have some announcements next, which means that we'll probably get them on the live stream, or will somebody join me? We'll see. Either way, thank you all for being here. Remember, the next session starts at 9:30, and we have some announcements coming up right now.
Hi, everybody. I hope so. Everybody can see me, can hear me. Can I have some feedback from the backstage? So we will have some announcements for our raffle okay. So I have the feedback for our raffle for the practicum scholarship. We will post on the general channel the link for you to fill it out. We will close that link by 12:30 when we start the next session. So during the break, if you are interested and you could fill out the form, you will be eligible to go to be pulled for the scholarships. And I'm not sure, and I think later we will send out the other form for the raffle in the end. And the word that you will have to put in that form is technical difficulties, because today we had technical difficulties. So write down this word, and when you will receive the second form at 2:30 p.m. EDT time, you will have form this this phrase, technical difficulties. Make sure that you get this link for practicum now in chat, and I let you go to fill out the form, networking, or anything else. Take a break for yourself, have some lunch or something. Thank you.
Hi everyone, sorry for technical difficulties. Just want to say, again, we are on break till 12:30. Please sit down, enjoy your lunches or coffee or whatever you're going to do. On screen, you should see right next to me, this side here, a QR code to the practicum and a link to practicum. I'm going to leave that up for a few minutes, so please enjoy that, and we will get back to you guys soon. The practicum link will be going down in about, say, 5-10 minutes. You can't find it in chat, and we will see you all at 12:30 for our next talk. Have a wonderful day. All right, everyone. Sorry if our screen was flipped there for a second. Again, our next talk is at 12:30. That's with Scott, talking about some interesting things in Flutter. This is just a quick reminder to everybody that at 12:30 we will be resuming with our presentations. Up next, we have Scott with a wonderful talk about Flutter. Also, remember the secret passphrase of technical difficulties for the form later today to be entered into our raffle. We have all sorts of interesting sponsored donated prizes. In fact, while we have your attention, a quick shout out to some of our sponsors. We'd like to thank Practicum, JetBrains, Well, who else do we want? Oh, O'Reilly Publication. We'd also like to thank Dan Sullivan, Wellframe, New York Tech Loop, Developer, and ROI Training. Also, we'd like to thank GDG community members like you. Hi, everyone. This is your roughly 2-minute reminder to our next speaker. That would be Scott with his wonderful Flutter talk. All right, everyone. A wonderful little lunch break just now. We're about to get started with our first of our afternoon talks. Sorry about that. I'm hearing myself. Not only were we in the mirror world for a little while, but I'm still hearing echoes of the past. So, anyways, just want to remind everyone that we'll be holding Raffle at the end of today's event. There will be a wonderful QR code over here. It'll be over here some way on my screen, along with the link for you all to follow. You will need to know the secret phrase of today. The secret phrase of today is technical difficulties. We have all sorts of things gives out. My personal favorite that we got from JetBrains today is we are giving out some 1-year licenses to their products. JetBrains makes a lot of great stuff. Their database solutions have more than once saved my butt in stressful situations. I do see that Scott has joined us. I believe he's just getting his last few things hooked up for audiovisual. Hope everyone's having a really good day. Thank you for sticking with us here on Bevy. Thank you also everyone who's on Twitch. Twitch is great, so thank you for showing up there. Again, we're sorry the chat's not turned on there. It's just emojis, so shoot emojis, lots of thumbs up and whatever. Well, Scott gets things set up. I figured I'll talk about what we had. I think this morning was actually really interesting. Firebase is a wonderful product that has a lot of really cool features. I really do enjoy the ability to have synchronized live document databases with little to no setup on my part. Not only that, but the Flutter integration, which I've used several times, is really very nice to work with. All right, and we're just waiting for Scott to set things up. So I'm going to take in
testing 1 2
and there's Scott. Hey, look, and here we are. Here we have Scott. I'm going to leave you with him for hopefully entertaining bit of information about Flutter.
Testing 1 2. Am I here?
You are here.
All righty. My apologies, folks. Interesting time for my laptop to refuse to boot up, and a lot of other things. Now, Rainier, could you drop your presentation mode? I'm trying to see if my screen is showing properly, and it's getting cut off while you're here. And looks like we do have, thank you. Looks like we do have a little bit of lag here. Now, I hope this is showing properly for everyone. I think it should be. Alrighty, my name is Scott Stoll. I have been doing Flutter for a while now, let's just say. Flutter came out in August of 2017. I got involved in September of 2017. Again, my apologies. This morning has been interesting. And as any presenter can tell you, interesting presentations are always the most fun ones. Anyway, we're here to take a look at something I call RenderFlex nightmares. Now, the interesting thing here that I'm looking at on my screen, my slides are inverted. Am I inverted? Or does this look normal? Okay. Thank you, Karina. All right. RenderFlex nightmares, rows and columns gone horribly wrong. There's a little humor in this. Not everything is to be taken seriously, and this is an intermediate look. If you are a total beginner to Flutter, this is probably going to seem a little overwhelming. If you're very advanced, it's Might seem a little bit beneath you, but hopefully there are some tips in here you might pick up. With that said, let's take a look here. Now, okay, that's not what I was supposed to click on. What's this all about? Okay, so what this is about is the fact that rows and columns are central to any layout in Flutter. Flutter, again, is a UI toolkit. Now, it's important for a lot of people new to Flutter to understand and really get a good grip on what it is and what it is not. Okay, Flutter is a UI toolkit. Flutter is not an operating system, but unfortunately, it's so capable as a UI toolkit, front end and back end, that people make the mistake of thinking it should do everything that an operating system does. So, what do I mean by that? Well, you might see some complaining on Reddit that Flutter doesn't natively handle the camera by itself, or that you might have to use a package to do things like access the IMU and the GPS. No kidding. It's a UI toolkit. It's meant for making UIs. It's not supposed to do those things. It's supposed to request them from the operating system, which is what the packages are all about. It's interesting to see people say that Flutter sucks because it doesn't handle these things. And to tell you the truth, I could say that Android sucks because it doesn't fold my laundry. It doesn't make it true. Okay, so if you see people complaining that Flutter sucks because it doesn't handle the camera or the IMU and stuff like that, straighten them out, please. It's a UI toolkit. It has been built as a UI toolkit since the day it launched 1.0. But for some reason, people keep thinking that it is supposed to do a lot more natively. And again, it can do a lot more. It's just people are writing packages to make that happen. But rows and columns are central to any layout, and that's why you should care. Okay, so what are rows and columns really when you get down to it? All right, in Flutter, there's something called a flex. Okay, now a flex is an item that can have multiple children in it, and it will change its size depending on the needs of the children, as long as it has room to do so within the room that its parent has given them. Flutter layouts are totally parent-child dependent, very much like HTML. Now, if you've been doing Flutter for a while, you might have heard of something else, and it's important to not confuse the flex with the render flex. The render flex is the render layer's version of the flex. Now, what do I mean by that? When you're writing Flutter code, you write in what's called the widget layer. You're writing in rows and columns and containers and padding and things like that. Then we have the element layer, which is a skeletal representation that basically only contains the type and a key. Now, the key is basically an instance name that is automatically generated. So now we have instances of your rows and columns that are named via keys. The way Flutter actually works on the render engine is it's only recreating things that have changed. So in the element layer, every frame, it's going to scan right on down everything in your UI and say, is this the same one that was here for the last frame? And if the answer is yes, it skips it and goes to the next one. Now, anything that has a different key than the last frame is going to be marked for destruction. They don't try to mutate it. We don't change the characteristics of something. We don't do that in Flutter. Okay, we consider mutation to be evil. We try to use immutability wherever possible. So we actually destroy the entire component and all of its children if it has been marked that it's been changed. We can get away with this because in Dart, the garbage collector is really, really fast. Think of it in another way, if this isn't making a lot of sense to you. And one quick note on the garbage collector, for those of you who do understand garbage collection, we're using both Young Space Scavenger and Parallel Mark Sweep. So if you know garbage collection, you understand what I just said. But in any event, going back down to a more intermediate level, picture that you built an Airbus 380 in your living room out of Legos, okay, out of little plastic blocks. If you're going to change the wing in Flutter, we don't try to take out the pieces that we're changing and replace them. We just destroy the whole wing and rebuild the whole thing all over again. Now, why is garbage collection important? Because when you do this, you're doing it in your bare feet. Okay. If you have children, if you had Lego blocks as a kid and you went walking around while they're scattered all over the floor in your bare feet, you realize how important it is to go around and collect them up. Okay. And that's what the garbage collector does in Dart, is it cleans all that stuff up when you destroy the old ones. So let's take a look. Well, to the end of that point, the render flex is the class that is used in the render layer that is the version of the row and column. That's because the flex is the superclass of the row and column. So we have a flex, and rows and columns are types of flexes. Rows and columns are really nothing more than convenience widgets to make your lives easier. Okay, because the flex, as I said, can have multiple children, can change its size depending upon how much size it was given. And if it is hard-coded to horizontal, then it's called a row. If it's hard-coded to vertical, it's called a column. You could just as easily write a flex and then set its direction, but that makes your code a bit harder to read. It's a lot easier to read your code by scanning it down if you see the word column rather than if you see the word flex and then you have to make yourself stop and double check which direction it's going. So that's why we have rows and columns. But when you really dig into it, what you're digging into is the flex. So if you take a look here, as I mentioned, there is a required direction. And horizontal equals a row, vertical equals the morning, vertical equals the column. Where's my coffee? Out of coffee. Another emergency. So anyway, moving on. The flex can have things in it that are called flexibles. Go figure. One of these flexibles is called an expand. Now, just as a row and column are types of flexes, the expanded is a type of flexible. Okay, now what an expanded does is it's a child that expands the row, column, or flex so that the child completely fills the available space. Well, available space. Okay, what is available space? Available space is leftover space. Meaning if you have a row and column and its parent said you have 100 DP available. And when I say 100 DP, if you come from Android, you understand that DP is density independent pixels. There are also SP and PX for regular pixels, all kinds of things. The nice thing about Flutter is we only use DP for everything. So when you see a dimension, when you see a height, when you see anything like that, a font size, it's all in DP. Makes our lives much easier to have it standardized. But the parent says, column, you have 100 DP of height. Okay, fine. We have one image that takes 50. Then we have a caption below it that takes 20, and we're not using the other 30. So what is the expanded going to do? It's going to fill out that other 30. Or what you could do is you could have the picture taking up 50, put the expanded, and then have your caption as a child of the expanded inside of it. And what that's going to do is cause the caption to take up the entire 50. And then depending on how it's aligned, your caption words could end up centered in the middle, could be up top, could be wherever you put it. So that's basically how it works. Flexes. Now remember, the flex with the small letter is not the same as the flex with the big letter. This is where you have to start paying attention. The flex is not the flex. This flex is equal to, in Android, gravity. So if you have two expandeds and you're trying to figure out which one's going to get how much leftover space, if they both have a flex of 1, then they're going to get equal space. If one has a flex of 2 and one has a flex of 1, one's going to get double the amount of the other. So the way you figure this out is you take the 2 and the 1, you add it to 3. One of them gets 2/3, one of them gets 1/3. Hot tip. When you're dealing with multiple expandeds, the easiest thing to do is make sure all your flexes together add up to 100. When they add up to 100, then what happens is you're looking at percentages. If you give 150, it gets 50%, 33%, 25%, etc., etc. So again, let's make our lives easier so we can read things at a glance. Now, I want to go back and revisit something for a moment. The definition of an expanded. It is a widget that expands the child of the row, column, or flex. Sorry, double checking our time here. It expands the child of the row, column, or flex so that the child fills the available space. How do I put this? This definition is not quite, that. There, that. It's not true. Okay, the easiest thing to get this understanding into your head about what's really going on is that's just not true. It is filling the available space that was reserved for it. Now, this is starting to dig into something called the multi-child layout algorithm. It is a 6-step algorithm that determines how all these individual children are laid out. If you try to read it the way it was written, try to not jump off a cliff when you're finished. Okay, I wrote an entire article that was a 4-part article. It's about 20 minutes to read the whole thing. It's called Render Flex Children Have Non-Zero Flex, but Incoming Height Constraints Are Unbounded. It is a deep dive into this subject, and it, I like to say, translates into human each of the steps in this algorithm. We're not going to go that deep, not into this, but you can look that up on Medium. So again, it is using all the space that was reserved for it. So what's happening here? To understand better, let's look at the flexible itself. Now, this again is the superclass of the expanded. The expanded is a type of flexible, just like a row or column is a type of flex. So the flexible extends something called a parent data widget. Don't ask, I don't know. Of type flex parent data, still don't know. But it has a key. It also has a flex. And in this, the flex is set by default to flex fit loose. Whereas in the expanded, it is hard coded to tight, which you'll see in a bit. So, and then it has to have a child. But here's the big difference. Unlike the expanded, the flexible does not require the child to fill the available space. All right. Now, as I said, the flex fit here is loose. What in the world are we talking about? Flex fit, the child is forced to fill the available space completely tight. It is not forced to do so. Loose, not hard. It's really not that hard. But let's conceptualize this a little bit, okay? Flex fit is easiest to understand by sticking a balloon in a shoebox. You have a balloon, it's in the box. What happens when you blow it up and make it expanded? Well, it fills the entire available space in the box and smashes itself up against the sides. It fits tightly in the box. So if you are expanded, it's going to fit tight in the space it was given. Only in the main axis. What the heck is the main axis? The main axis in a column is vertical, and in a row, it's horizontal. It's the direction. Okay, so that's what the main axis is. It's the direction. what I just said. Now, everybody's favorite part of the presentation. Pop quiz. It's everybody's favorite part of everything, isn't it? No, definitely not. Okay, moving on. The Flex Fit quiz. These are the actual constructors for these things, and this will help us to understand something. Here's the flexible, here's the expanded. The flexible, you can set your fit to tight or loose. If you notice, that's missing here. That's because it is hard-coded right there. You don't get any options. The strengths in this one are equal. We're just going to use this constructor as our example. So in all the leftover space, we're going to reserve half of the leftover space for each one. So we have 80 left over. Okay, we had 100 available and we used 20. Now we have 80 left over. What happens in the algorithm is it looks at the flex for each one and it says, okay, the flexes are equal. I'm going to reserve the same amount of space for both of these. Each one's going to get 50%, so each one's going to get 40. However, remember, this one is not required to use the whole 40, but this one is. So what's happening here? What's happening is, let's say each one of these has a child that takes 10. So now we have 40 reserved and 40 reserved, needs 10, needs 10. But they're not going to come out the same. Why not? Well, that has to do with the nightmare. Okay, I'm sorry. What if it doesn't use all the space? What is going to end up happening, let's take a look at this first, is that the one that is loose is going to need 10, and it's only going to use 10 because it's not required to use all the space reserved for it. The expanded is required to use all the space reserved for it, so it's going to use 40. So what you're going to see is your column is going to use 20, and then it's going to use 10, and then it's going to use 40, and then you're going to have 30 of blank space. I didn't say blank space under the column. That's what it looks like, though. When you're coding this and you look at what you're doing, you're going to get frustrated, saying, why is my column not taking up all the available space? And the answer is, it is taking up all the available space. There's 30 blank inside the column, and that's transparent. That's what's allowing you to see what's behind the column, making it look like the column finished short. It didn't. It's taking all that space. That is, as long as the main axis is set to main axis maximum, which is the default, which is why you're probably going to have a column taking up all the space. If you set your main axis to main axis minimum, then your column really is going to end short. So there's another one for you. The main axis determines whether the main axis has to take up all the space. Now, what is it when something takes up all the space? It's tight. If you set it to minimum, then the constraints put on the main axis are loose. So now we dig into the nightmare. Render flex children have non-zero flex, but incoming height constraints are unbounded. Don't be that guy. You never, ever want to see the magic smoke come out of your laptop, okay? Because it's very, very difficult to put the magic smoke back in the laptop, and just get a new laptop. We mentioned constraints. What? Constraints. What is an easy way to put this into human? Okay, constraints. Good fences make good neighbors. Okay, fences, limits. Okay. They also make functional layout algorithms, because without constraints, believe me, your layout algorithms are not going to function. So render flex children have non-zero flex, but incoming height constraints are unbounded. I need to quote a very wise person here. If inherited widget is Flutter's monad, then render flex children have non-zero flex, but incoming height constraints are unbounded is our boogeyman. Okay. It's wise person. Umonero. Hombre boogeyman. Okay. Mummus. Baba Yaga. Whoops. Render flex children have non-zero flex, but incoming height constraints are unbounded. You know what? As many times as I've said it, you've probably seen it at least 100 times more than that if you've been coding Flutter. Here's what it boils down to. Something's trying to be infinitely big in the main axis. Nothing's there to stop it. Fix it. Okay. So constraints, you have maximum and minimum. Well, they're fences. Maximum is the biggest something can be, and minimum is the smallest that it's allowed to be. It blinks when I check the time. I don't know why. So if we're not contained within something, we're going to try to blow out. Now, when you're dealing with constraints, an interesting thing that nobody really talks about, and I think I probably should write an article on, is there are widgets that pass down the constraints that they're given. There are widgets that have no constraints at all and don't put any constraints on anything. And then there are constraints that are loose. So what's going on here? A constraint that passes through what it gets is like a container, but it passes them through tight. So if a container is told by its parent that it can be 100 by 100, the container is going to look at its child and say, you can be 100 by 100. And by the way, you really have to be 100 by 100 unless something changes that. What can change that? Well, you can turn around and put an alignment or an align widget inside of that. Because what's happening is once you have to start aligning things, you can't align something that's fully expanded. It takes up all the space. Right? So if I'm going to align it left, it's got to be smaller than the space that's in it so that I can align it left. Common sense. So when you put something in an align, which by the way, the center widget is nothing but a convenience widget for align. The default align is already set with its alignment to alignment.center. But again, you're reading the code quickly. You don't want to have to stop and say, which way is this alignment? You want to be able to go, okay, this is a row and it's got a container and it's going to align its child center. You want to be able to read it quickly. So that's why we have a center, but it is nothing but an alignment. But if you use that, it's going to break those tight constraints and it's going to give loose constraints to the child so the child can shrink down. And then once it's not as big as the space available, it can be aligned within that space. So that's one of them. What's an example of something that doesn't give any constraints at all, tight or loose? A flex. We've been talking about it the whole time. Rows, columns. What's an example of a tight constraint that forces the child to be as big as it can be? The expanded. What's an example of loose? The flexible. You know, there are a number of others that can do a lot of things like that, such as the positioned is another one that loosens up constraints. The positioned isn't used within a stack. You would think that a stack is nothing more than a vertical row or column. It doesn't work anything like that. Just don't. Learn that as its own separate thing. Now, moving on. This next part is not in any way, shape, or form totally serious. Okay. Don't let this make your brain hurt too much. Don't take it too seriously. However, when you come away with this, when you come away from this, you need to understand something. You must remember, Padawan. A flex is flexible, but don't confuse the fact that it can be flexible with an actual flexible. It's not an actual flexible, it just is flexible. A flex fit has nothing to do with the fit of the flex. Flexes don't fit. Flexibles fit. The fit of a flexible determines the strength or gravity of the flexible, except when it doesn't. Because if it's loose, then it's not determining any gravity. It's just hanging out, not really doing anything. It's just letting the child be whatever size it's going to be. Now, you can set the flex to 9 gajillion, but if your flex fit is loose, it's going to be ignored anyway. It isn't doing squat. Okay. Now, the flex fit, that's true. The flex fit of the fit determines if the flex of the flexible will be allowed to flex the flexible so that it better fits into the flex. Don't confuse the flex with the flex, or you're going to end up. Were you expecting something else? Confused? Of course you are. The last slide nearly confused me, and I wrote it. Fortunately for all of us, there are plenty of places we can get help. Gitter is the official chat channel of the Flutter team. Word of warning, Gitter is single-threaded. Every GitHub repo gets its own Gitter. No one ever uses it. Why? Because it's single-threaded. What does single-threaded mean? There's one channel for everything. Beginners, intermediate, advanced, people talking about the weather, doesn't matter. It's all flying by like a stock ticker. And if somebody doesn't at you when they're answering your question, then you're stuck digging through the whole thing looking for relevant information that you can use. Painful. The Flutter Dev Google group is a great place to look. I happen to know that the Flutter team themselves do look there. I have seen even the lead engineer, Eric Seidel, answering questions personally. On Reddit, you want to use Flutter Dev, not Flutter. So that's a great place to go as well. The Flutter community medium, I don't even know anymore. We're probably pushing 2 million minutes read every 30 days, 1,000 articles or more written by people who have been around for a very long time. Just about every Flutter GDE has put articles into this. When I say everyone, I mean every single one all around the world, from India to Germany, everywhere. The Flutter community page on Facebook is very low traffic, but it is there and you can check that out. Twitter, of course, #Flutter. If you want to contact the Flutter team on Twitter or track what they do, there's @flutter.dev. If you want to follow some really cool people, then check out this loser right here. Okay, because I tend to follow some pretty good people. And then there is Hump Day Q&A, and actually this has changed. It is now bit.ly Hump Day Q&A every Wednesday, and you can just swing in and hang out. So that way you can get live help and ask a human being. Now it is 5:03. Rainier, I take it you need to set up the next person. Do we have much time for questions? Again, we have lag. Please be patient. Aha, Rainier.
Sorry about that, everyone. We are, as Scott said, getting some serious lag. Of course, now my camera's on. Start my camera.
I feel like I'm
all right. Look, Scott's face is still on my camera. Let's put my pretty face up there. All right. So,
thank you all.
All right. So, everyone, say thank you to Scott. Scott, thank you for that wonderful talk on Flutter and for taking and talking with the Flutter community, which I'm always a fan of. If y'all don't know, I'm a huge Flutter fan. I like the fact that it sort of just sits on top of whatever host operating system's in, lets you write all your wonderful host operating system code and then talk back to it using RPC, which using protobufs, which is great. Let's just have to do that. All right, so next up we have your host's inability to take and use its own stream deck. All right, so next up we have another machine learning talk with Dan Sullivan. Also, just a quick reminder to everyone, after Dan's talk, we will be putting up a slide for everyone to fill out a form for the raffle. We actually just did a count, about 38 different things to give away today. That's things like O'Reilly book subscriptions, JetBrains licenses, gift cards supplied by our wonderful sponsors. Just so everyone knows, that includes our sponsors like Practicum, Wellframe, JetBrains, obviously, O'Reilly, Gaspacio, and all that sort of stuff. I'm getting reports that we are having some issues with Twitch. So let me go to, and Dan is here. Dan, if you want to take over, and are you ready?
Sure. Hey, yes, I am ready to go. Let's see. And share my screen. Jump over to PowerPoint. Okay. Well, thank you for joining the conference today. And as you just heard, this talk is another machine learning talk. And in particular, what I want to take a look at is automated ML techniques. And basically, I want to try and address the question, with automated ML, does that mean that we're all machine learning engineers? And we'll see by the end. The answer is no, it's not quite that simple. But the automated tools really are pretty powerful. So first, some quick background. I'm a principal engineer. I focus primarily on cloud and data technologies. I'm also an author, most recently, of 3 of the official Google study guides. And then also I have courses on Udemy and LinkedIn, mostly around cloud and data science, machine learning topics. So if you're familiar with cloud products and you've maybe worked with any of the 3 major ones, you've probably come across or seen some mention about automated ML. Like in Google, they talk about being able to do machine learning with minimal machine learning expertise. AWS goes even farther to say, it's machine learning for every developer, and Microsoft has similar kinds of things. And while this is really true, there's a lot that the automated ML techniques do for us. It doesn't actually cover the whole spectrum of things that we need to do in machine learning. And so what I'd like to do is kind of take a look at, first of all, the machine learning workflow. So where does this auto ML stuff fit in? And what's left over, what's not covered by AutoML that we still need to be able to basically handle on our own. So we'll start off with that. We'll look at how you go about, what's required to formulate a machine learning problem. And then I want to spend some time looking at services that are available in Google Cloud for building machine learning models. And we'll look at both automated tools and other tools that are more sort of build your own, do it yourself kind of machine learning tools. And then I also want to talk about services in GCP that are used for data engineering, because really that's the bulk of the work that isn't covered by AutoML. But there are a lot of services that we can use, so we'll take a look at those. And then finally, I want to take a look at monitoring machine learning models that are in production. And an increasingly important topic is evaluating fairness, because if we're going to start using algorithmic decision-making, we have to make sure our models comply with the same things we would expect a human to comply with. So let's take a look at formulating an ML problem. Basically, there is a machine learning workflow, and this is pretty standard. People seem to have adopted this pretty widely. The first is that we formulate the problem. So we have some kind of business problem or a question or a science problem that we're trying to deal with. And we have to make sure we can sort of frame that in a way that we can apply ML techniques. So this is, in some ways, this is one of the hardest problems. Another hard problem is identifying data sources. So we need to know where we're going to get our data, and also understanding what's the quality of the data. What do I need to get the data in a format where I can actually use it with an ML algorithm? Sorry, my dogs are going to join in here. Yeah, there's the second one joined in. Let's see, we're going to focus now. I'm kind of shifting gears. So the items in red are things that aren't really covered by automated ML, and the things that I'm bullet items in black are really the focus of automated ML tools. So training, evaluating, and tuning models, deploying a model to production, so just like deploying software in a CI/CD pipeline, and then using the model in production, and then finally, evaluating fairness really isn't covered by automated ML. Monitoring is somewhat, but there's probably more monitoring that you should be doing than is available in some of the automated tools. So how do we define the problem to be solved? Well, usually we start with some kind of informal description. Like if you work for an insurance company that sells health insurance, you might want to predict people who are in the hospital, maybe having, say, a hip replacement surgery or a knee replacement surgery. You want to be able to predict which of those patients, when they leave the hospital, are most likely to, say, fall and have to be readmitted to the hospital. And you want to know that because that, one, it's another injury to someone who's already had surgery, and two, it's going to cost you as the insurance company more money. So you want to be able to sort of formulate a problem in business terms at this level, and then leave the sort of technical ML stuff for later in the process. So one of the things you need to understand is what's the value of solving the problem. And I've seen this many times where engineers have really deep interest and deep understanding of ML algorithms and find a way to apply that or can see a way of applying that to a particular problem. And the only snag with that is that particular problem that they may be looking at isn't really of much business value. So yes, it's interesting from a technical perspective, but not necessarily from a business perspective. So we want to watch out for that. And you want to think about how the problem can be solved. So in particular, we want to know, is this a regression problem? Do we want to predict a continuous value? So for example, do we want to predict the selling price of a house in a particular market? Or is it maybe a classification problem? So for example, you might want to identify, in a radiological image, is this an example of, say, a malignant tumor in an MRI image or an X-ray image? So those are classification problems and regression problems. Those are really probably, they cover a wide swath of the kinds of problems we take on in machine learning, and they're definitely the ones that are covered the best in automated ML tools. So another thing you have to do is basically identify data sources. And here, one of the problems is we sort of have, almost too much of data available to choose from. So we have to be able to identify sources, and we want to understand certain characteristics of the data sources. So for example, we want to understand, what amount of data is available. And this is especially important when we're working with supervised machine learning algorithms, so regression or classification, because in those cases, we need what's called labeled data. So we need to be able to understand what are examples of, say, something that has in a certain class and something that's not in a certain class. Or, we have, if we're doing a regression problem, the amount of the sales price of particular houses. So we need to understand what's the amount of data available, and is it sufficient, and is it high quality enough to allow us to actually build a model using the particular tools that we have available. We also want to think in terms of the rate of the generation of data. Is it very sort of sparsely generated data? We don't get a lot of new data. That's important to understand for things that we'll look at later. One of the things is, for example, is known as data skew. So if you build a model today with a certain set of data, maybe if over time, say patterns of behavior in your customers might change for some reason, you want to make sure that you have enough fresh data to be able to capture those changes in the model as well. And then another key thing to think about is, what are the requirements to get access to this data? So this is especially important if you're working with any kind of healthcare data or financial data or anything else that might be protected under certain kinds of government or industry regulations. And with those requirements to access, there may be limitations on the use of the data. So for example, if you collect data from your customers using mobile apps and you're collecting, say, geolocation data, there may be restrictions on what the customer has agreed to with regards to the data. So you want to make sure that, you know, early on in your problem formulation stage, you're paying attention to that. So once we have the problem and we have a good understanding of what we're trying to do, then we can start thinking about, like, all right, what are the tools we can use to actually build a machine learning model? Now, GCP is a great platform for building models because there are so many options. So there's Cloud AutoML. There is an AI platform training, which allows you to use sort of standard tools that we often use in ML and run them in a sort of a managed environment. Kubeflow is a widely adopted machine learning pipeline that runs in the Kubernetes environment. We also have the option of using Cloud Dataproc, which is a managed Spark Hadoop platform. And Spark has a pretty rich machine learning library. And then also recently, BigQuery, the serverless data warehousing service, added machine learning capabilities into BigQuery SQL. Now, Cloud AutoML is really a great example of an automated machine learning tool. So it really is designed for model builders with limited ML experience. And it provides a GUI for actually managing all of the training, evaluating, and tuning processes. Now, included in Cloud ML are sort of sub-services which specialize on things like machine vision, language processing, and also working with structured data. The structured data one is called auto tables or AutoML tables. And literally, you can start with a sort of say a pandas data frame, an Excel spreadsheet, a table or view in SQL, and that can be your starting point. And AutoML can actually work with that and start developing regression and classification models for you. Yeah, so as I mentioned, it uses structured data to build these models, and that's as opposed to unstructured data like images, natural language text. But for unstructured data, there are these other specialized services. So the AI platform training service basically allows you to train and run models that you build in commonly used machine learning tools like TensorFlow. Scikit-learn is a widely used Python library, and also XGBoost, which is available. You can access XGBoost through Scikit-learn. It is really one of the best, highest performing tools in a broad range of, or algorithms in a broad range of machine learning tasks. And TensorFlow, I'm sorry, I should have mentioned, is used for building deep learning models. Now, when you use the AI platform, you can use some pre-built frameworks and containers, but you can also run your own custom container as well. And basically what happens is with the AI platform training, the service will provision whatever sort of compute resources you need to run the job and actually keep the job executing. So this allows you to focus on the model and building the model and tuning the model, and less on sort of concerning yourself with, provisioning resources and, thinking about like scalability and how many containers you should be running. Kubeflow is a service that's used in Kubernetes. So if you're already working in a Kubernetes environment, this is a good option. And basically, it allows you to package your models like applications. So it really fits well with sort of the Kubernetes framework. And like with automated ML tools, with Kubeflow, you can compose, deploy, and manage the ML workflows. Now, I mentioned Dataproc, and again, that's a managed service, and it really was designed for allowing people to migrate their Hadoop or Spark clusters that might be on premise into Google Cloud. And now Spark also has an ML machine library, which is really rich. It's been around for years, and it has a wide number of ML algorithms. It also has tools to support feature engineering. And feature engineering is one of those sort of processes in the sort of the broader data engineering task, where you basically work with your data to try and come up with features or attributes or columns in your table which show useful information from a machine learning perspective. It helps you discriminate across, say, classes, or it gives more information to the regression algorithm for building models. So sometimes we need to combine features, say take a ratio of two numbers or something like that. That's a kind of feature engineering. It also has pipelines. So if you're familiar with Spark, or you've been using Hadoop and you want to work in that environment, you can still build pipelines and manage large segments of your workflow within Cloud Data Proc. And you can persist your models, and also there are a variety of utilities for working with data. Now, one of the most interesting sort of features, at least from my perspective, with regards to machine learning in Google Cloud, is the introduction of machine learning libraries into BigQuery. Now, again, BigQuery is a serverless data warehouse service, and although it uses SQL, it's not a relational database. It's not like Cloud SQL or Cloud Spanner, which we use to build, say, transaction processing systems. BigQuery really is designed for sort of analytics, answering queries that maybe query a relatively small number of columns, but need to go collect that data from many, many rows. Also, it's not great for updating, like in terms of, once you write a row, typically in BigQuery, you don't update it. You're constantly adding data. So BigQuery, again, it's not a transaction processing system, but it does use SQL. And now we can use SQL functions to build machine learning models right in SQL. So if you're familiar with SQL and you want to build machine learning models and you happen to be working in sort of an analytics environment and you're working with BigQuery, definitely take a look. It's really easy to do. And some of the key advantages are you build and train the models right in BigQuery. You make calls using SQL functions. So you don't have to work in a different environment like scikit-learn or TensorFlow. And again, the other thing is you're using SQL. So if you're not familiar with Python or the other machine learning frameworks, you can still build a classification model or a regression model right in BigQuery. Okay, so those were the services. And now I'd like to shift gears and sort of talk more about sort of the high-level processes that are part of the machine learning workflow. And a big one, as I mentioned earlier, is data engineering. Now, one of the tools that Google provides for this is something called Cloud Composer. And it's another managed service, and it's based on the Apache Airflow service. And basically what it does is it executes workflows that are defined as directed acyclic graphs. So I'll show an image in a second about more about what that is. But the idea here is basically what we do is we specify like a whole series of events that we might need to do. For example, we might need to check and see if a file has been dropped into a cloud storage bucket. And then if it has been, then let's do some quality control checks to make sure it's meets certain characteristics, and then we do some pre-processing. Then we train our model or do some feature engineering, and so on and so on. Well, Cloud Composer is a great tool for organizing all of that as a single unit and being able to manage those as a single unit. Now, like other GCP services, you can work through either the console or the command line. So here's an example of a workflow that's defined as a directed acyclic graph. So we have our starting event A. So that, again, that might be a file being dropped into cloud storage. And step B might be a quality control check to make sure the data is in the right format and structure. And then if it passes B, then a series of other tasks, C, E, and D, are executed. Now, before D can execute, maybe something else has to be in place, say G. So for example, another piece of data, say some reference data that you want to combine with B, has to be in place. And so when both of those are in place, then D can do a join, and then it'll produce output, which is combined with the output of B and C, which is processed by E. And then finally, E does something else and maybe wraps up the data and pushes some output or makes a prediction and pushes it out in step F. So all of those tasks, you can coordinate, you can run, say, using cloud functions and trigger one after the other. But one of the nice things about using Airflow is that there are a lot of sort of process controls already built in. So for example, if you have to wait on something, it's very easy to specify how to wait. Or if a task fails, you can easily specify how many times to retie before failing the entire workload. Now, when you specify a DAG, it's basically a specification or a script, and it's stored in cloud storage. And there are a lot of plugins and operators so that you can work with different kinds of tools like different databases, or you can run a command on a bash shell script. And Airflow is also based on Python. So it also works with Python dependencies. So if you have to import packages and things like that, it's fairly easy to do. So here is an example DAG specification. Again, this is in Python, and if you're not familiar with Python, but you are going to be working a lot with machine learning, then I would really encourage you to learn some basic Python. You don't have to be an expert by any means. Even some basic just scripting knowledge, being able to do a minimal sequence of steps and maybe some conditional logic, just really basic programming. A little knowledge of that in Python goes a long way in machine learning. And not only would you be able to say, for example, to specify the DAGs, if you have to step into other programs like scikit-learn or TensorFlow, then you can use Python with those as well. So it's definitely worth looking into Python. Now, Cloud Composer works with the idea of environments, and they're basically a set of services that are run within Kubernetes engine. And it uses a combination of what are known as tenant and customer project resources. And so here is a sort of a diagram of the Cloud Composer architecture. And over in the sort of the blue section on the left is the customer project. And those are things that are resources that run in your project. Then there's also a set of services that are actually managed by Google. So they're not really managed by you at all. But this is part of more part of the managed service. This. So there's two components. Just again, and I mentioned this only in case you dig into Cloud Composer and you start hearing about tenant projects. The key thing to remember about that is that's stuff that's strictly managed by Google and not something that you necessarily really have to. Cloud Data Fusion is another tool you may want to use for data engineering tasks. And Cloud Data Fusion is, again, it's a managed service, and it's based on another open source tool. And basically, it's an ETL or ELT development tool. And ETL stands for extraction, transformation, and load. And ELT is just a switch of that, of extraction, load, transform. And the idea here is that a lot of times we're pulling data out of source systems. So the data sources might be cloud storage, it might be a cloud SQL database, could be a NoSQL database like Bigtable. And so pulling data out of databases and then doing some operations on them, sort of cleaning them up, reformatting them, transforming the data, that's a very common task. And it's really nice if you have something like a code-free ETL tool, because it saves you time. Now, Cloud Data Fusion has a large number of connectors, which allow us to get the data, and a large number of transformations, which allow us to manipulate the data. So, for example, you can reformat data, change the structure or the way dates are formatted pretty easily. And it uses a sort of a GUI environment. So we have drag and drop construction. Now, that's sort of what the tool is like in terms of how it's deployed. It's deployed as an instance. Now, there are two editions. There's the basic, which has a visual designer. It has the transformations. You can work with SDKs. And then there's also an enterprise version, which has all of those things. Plus, you can do things like capture streaming data in pipelines. You have tighter integration with metadata repositories, and you have high availability features as well. So Basic is a great one to sort of get started with. So if you're learning, definitely take a look at that. If you're using it in production, or if you need to be able to work with, say, streaming data, then you probably want to take a look at the Enterprise Edition there. So here's just an example of the Cloud Data Fusion visual interface. And if you've ever worked with other ETL tools, this probably looks like a very familiar format where you have a palette on one side, and within the palette you have things like connectors to sources, or you have sort of common transformations that you might apply to certain different data types. And it's basically a drag and drop, and then connecting between components, and then specifying say operations like what are the inputs and outputs and things like that. So once we've sort of formulated our model, built our model, have our services up and running, and have gone through all of the sort of the data engineering work, then sort of one last piece we need to do once a machine learning model is deployed is, or even before deploying, we want to be able to monitor it. We have to set up and understand what are the performance characteristics of the model. And really there's two types of monitoring that we're doing. There's sort of the application specific, how are we doing from a resource utilization perspective? What is the responsiveness of the model? What's the latency in making predictions? There's that kind of operational monitoring. And then there's also the monitoring in terms of the quality of the decision making or the predictions that are being made. And again, fairness is a particularly important topic on that front. So with monitoring, our objective is to understand the performance of the model. So this is just very similar to understanding any application performance. So there are certain metrics we want to monitor. So we want to, for example, look at traffic patterns. Are we getting more data from some sources than others? Error rates. So is the model failing? Are we getting, say, error rates, especially in our ETL or quality control checks? We also want to understand latency. So how long does it take to, say, return a prediction? Or we also want to look at, say, what's the latency of extracting data, say, from a cloud storage or from a database. If the latency is increasing, that could be indicative of a problem. Now, sometimes latency problems, for example, with making a prediction, it could be a problem with the model. The model isn't performing very well. Or it could be latency in a data engineering task, like extracting data from a database. And if that's the case, then we might have to, say, look at some SQL queries and see if we need to tune those to increase the efficiency and the performance of those queries. We also want to understand resource utilization because cloud resources are typically, allocates and pay for what you allocate. We want to make sure that we're getting, efficient use of our resources. And we don't want to over provision and we don't want to under provision. So metrics that help us understand resource utilization are really useful. And we also want to be able to say, for example, to configure alerts in cloud monitoring. So cloud monitoring is one of the services that used to be a member of what used to be called, Stackdriver. Almost forgot that there for a minute. And Stackdriver has been broken up, and now it's called like cloud monitoring, cloud logging, cloud trace, and so on. Now, one of the things about cloud monitoring is you can create alerts. So if you're familiar with things like Prometheus or Datadog, cloud monitoring does similar kinds of things. You can specify metrics and thresholds, and say your CPU utilization goes over 80%, you can get an alert or have it trigger an alert and let you know that you need to take a look at that. So just as you do these kinds of things with regards to monitoring with other applications, you want to think about how you can do them with your machine learning models as well. Now, AI platform, for example, can export metrics to cloud monitoring, which makes it really easy to just use the cloud monitoring interface to be able to look at metrics and also set up alerts. And we can get things like error counts, the latencies I mentioned, Accelerator utilization. So in addition to say, looking at CPU utilization, oftentimes with machine learning, because there's so much math that's going on behind the scenes, especially in the training phase, we often want to use, say, maybe a graphics processor, a GPU, or a specialized accelerator which Google developed, which is called a tensor processing unit, or TPU. And so those are additional resources that we can add, say, to our instances or to our containers. And when we do that, we want to make sure that we're using them efficiently. And you may not be able to tell just by the behavior of your model. So getting metrics on accelerator utilization is really helpful as well. And then, of course, there's other sort of standard metrics like memory utilization, CPU utilization. We want to make sure we track those. And also networking utilization. Oh, I mentioned latencies earlier. Of course, a network can also be a cause of latency as well. So you want to watch for that. Oh, and then there's some sort of ML sort of specific metrics that we can get out of the AI platform. For example, how many predictions have been made in the last minute or hour? So we can understand what's the, how are other services using the models that we've deployed. Now, some best practices. We want to monitor for data skew. And again, I mentioned that briefly in the beginning of this talk. Data patterns can change over time, and sometimes they're cyclical. So for example, say you're an e-commerce site and you're noticing certain buying patterns, and they may, say, change by the season. So people will buy certain types of products in the spring or the summer, but shift away from those and buy different ones in the, say, fall and winter. Well, if you build a model using data that's based solely on spring and summer, then it's probably not going to work so well when you start hitting the colder months. So what that shift in data across, say, the entire data set that you work with and over extended periods of time is known as data skew. So you want to make sure you monitor for that. Is your data changing? You also want to watch for changes in dependencies in your workflow model. So you may have upstream dependencies, like you depend on, say, an application or an app that's generating data and it's writing data, say, to cloud storage. Well, what if the developers of those applications decide, oh, we want to start using Cloud Firestore instead of cloud storage because we want, a lot of the benefits that come with using Firestore? Well, that's going to change some of your ETL processes or ELT processes. So you want to make sure that you have a way of detecting changes in upstream dependencies that might affect you. Also, you want to make sure that models are refreshed as needed. And this really will vary. Some things, again, like consumer purchasing patterns may change fairly frequently, while other things like, say you're in a scientific domain and you're, say, developing models for categorizing radiological images, that might not change as much. The models may be fairly stable over extended periods of time. So you just want to understand, like, in terms of your own domain, how frequently the models should be refreshed. And then a really important best practice with regard to modeling is sort of assessing the model prediction quality. So when it's in production, you have to really, as best as you can, try and get a sense of how well are you making predictions. This is especially useful. So if you're predicting whether or not say a transaction is fraudulent, say a credit card transaction is fraudulent, you'll be able to know, like, say, in a short period of time, whether or not a prediction was accurate or not. So you want to be able to use that data to determine, how well your model is performing, and you need to go back and, say, maybe do some more feature engineering or tune the model in some way. And then a really important one is, again, testing for unfairness. Now, fairness is a kind of in a lot of ways, it's an ancient concept with regards to machine learning. It's fairly new in the last, several years. And it's basically the idea that we want our models not to be biased and not a bias is a little bit of an overloaded term. Like when in machine learning, you often hear the term or the terms bias and variance, and that has a specific meaning within machine learning. But people typically use the word fairness instead of bias when we're talking about, are we biased in the predictions we make? And there's two ways of thinking about bias. One is, fairness. Sometimes we think in terms of statistical patterns. So for example, if we're making decisions about who to give a mortgage to, and we have two subgroup populations, A and B, we would expect to get the same sort of predictive quality and measures of, say, false positives, false negatives across both A and B. If we're, say, have more false negatives in the B category, then we're not really being fair. So we want to be able to watch for that. So that's at a statistical level, and that's one way to define fairness. Another way to define fairness is at an individual level. So rather than looking at a broad category, we look at, say, two individuals, say two customers, and if they're very similar, then the general idea is they should be treated similarly. And so there's a lot of research going on in fairness research, and when you should use statistical models and when to use individual models, and how do you measure fairness across all of those. So it's a really active area of research. So what I just want to cover today is just first introduce the topic, and then introduce some ways that we can sort of work toward improving the fairness of our models. Now, one technique is called anti-classification. And basically, it's a really simple idea, but basically we just protect certain attributes and we don't use them in the model. So for example, gender, if we're making, credit decisions, then gender really shouldn't be a factor. So, why use it in the model? Why use that in the training data or the evaluation data? So if we exclude certain attributes, that's an example of anti-classification. Now, classification parity is an example I mentioned. So this is the idea of that statistical fairness, like you have two subgroups or three subgroups or n subgroups. You want to make sure the performance is relatively the same across all of the groups. And then there's also this idea of calibration. So as you're making predictions, you want to make sure that the outcomes are independent of predicted attributes or protected attributes. So for example, if you're making credit decisions and you're finding that you're denying credit to a certain subgroup more than you would expect, say we're working with gender, and there's a certain gender category that you are denying more often than others. Now, this can happen even if you're excluding gender, because there may be other data attributes in your data set that highly correlate with gender. So even though we exclude the one attribute, there's other pieces of information that highly correlate with gender, and maybe for some reason we have a bias or we're unfairly using those correlated attributes. So calibration is a way to detect that kind of unfairness. Now, it's such an important topic that I just want to point out some resources. There's Google Machine Learning Fairness has a great description, and here's a link to that. IBM's also done research, and they have some information and tools. FairML is an open source tool for doing sort of interactive fairness evaluation of your models. And Google also has a what if tool, which again is an open source tool which you can get on, is available on GitHub. So I just want to kind of wrap up. That was a kind of a quick overview of machine learning and this idea about automated ML. As you can, I hope you can see from this point of view that there's a lot more to machine learning than just running some data through a training algorithm. So the key takeaways are that machine learning workflows, they're really multi-step, that automated ML addresses some, but not all of the steps, and that at the end of the day, there's still a lot of data engineering and other work like ETL work and monitoring that's still required. So with that, I'm going to wrap up, and I would be happy to take any questions. And also feel free to connect with me afterwards if you have questions. I'm on LinkedIn at Dan Sullivan PDX, so feel free to message me or connect anytime. Thank you. Stop sharing.
All right, thank you very much, Dan, for your talk. If anyone has any questions, they should just put them into the question and answer section on the site. I'm seeing that we've got a few in here. Dan, first off, thank you. So we have one from Karen Unknown. Kubeflow package models like an application. Is it like a Docker image?
Yes, it's a container, right? Everything gets containerized. So yes, basically what you're doing is taking your model and treating it like really any other piece of software that you want to put, say, into a Docker image.
All right, do we have any other questions for Dan?
No. Okay. Well, again, if you think of questions afterwards, feel free to message me. I'm always happy to take questions and talk about this. Great. Well, thank you.
All right. Well, everyone, so that was Dan. He was our final speaker of the day. Dan, if you want to just pop off the stage. All right. So, unfortunately, everyone, this does bring us to the end of DevFest Northeast 2020. It's been a long and interesting day. We've had technical hiccups, and now it's for the part you all really are here for, the prizes. So before I do anything else, I want to thank everybody for showing up today. I know times are tough and it is Halloween, but I hope you all enjoy things. I want to thank our sponsors, which you'll see over here. So that's people like JetBrains, TechMakers, Gaspacio, Developer, I Am Remarkable, Practicum, New York Tech Loop, ROI Training, and Wellframe. And also O'Reilly, but apparently O'Reilly is stuck in the shadow world because their logo is coming through as just a black box. No idea why that is. Of course, also we want to thank GDG Platform for getting us all here. Put up chat so I can see if people are talking at me. For anyone who, actually, you all know what the GDG is. You're here. It's Google Developers Group. We're a community-driven bunch of people trying to serve our communities with interesting tech talks and community-based events. So for the raffle today, we're going to just go over how it works real quick and then I'll put the link up. The way the raffle works, you in a few moments will see over here a QR code and a URL. They both go to the same place. It goes to a Google form. Put in your name, your email address, and the phrase for today, technical difficulties. By doing that, we will know you are sitting here listening to this stream. Then we're going to spin a wheel and give away prizes. We have a lot of prizes to give away, about 30, I want to say 38. I know I'm probably forgetting a few. That's because we have so many prizes. Okay. Oh, look at that. We've got all sorts of thanks for Dan. And again, thank you, Dan. Your talk was wonderful to have. It's always great to find new and interesting ways to deal with data science without having to fire up, well, the entire data science cluster. All right, and with that, I'm going to be transitioning over to the QR code in 3, 2, 1. Magical transition. There we go. That is the QR code and the form for this raffle. Just take and go there. Either scan with your phone, use Google Lens, use some artificial intelligence right here, right now. Okay. So the URL is on screen. All right. Somebody will also paste the URL. There we go. Linda just pasted the URL. Everyone, remember, you need your name, your email address, so we can actually, send it to you. Well, you can't just send it by owl or mail or telepathy. Although, hold on, let's try. It is Halloween. Let's try some telepathy. Nah, it didn't work. All right. So, name, email address, and finally, the secret phrase today, which was technical difficulties. Remember, technical difficulties. And we're going to give everyone, say, 10 minutes to fill that out. But don't feel bad if you don't win anything, because everyone who shows up today is getting a 1 month access to O'Reilly Books. That's right, 30 days of access to O'Reilly Books. Just go to the link that Linda will be pasting in chat in just a moment and use the code DevFest20 to start with your free trial. Rebecca, you were asking, the passphrase is not case sensitive or space sensitive at all. Or spelling. If your spelling is bad, that's okay. I cannot spell. In fact, if you can't spell, that's a wonderful technical difficulty. Yeah, apparently O'Reilly didn't want to show up on the logo form. They want to stay in the Shadowverse, but they are caring about us. And we all love books. Although I would like to get out of this box I'm stuck in, because it's very small. Small box. Small, tiny little box I live in. Step back. We're using the most sophisticated AI on the planet. I'm seeing some bad puns in chat. I'm just going to take and go in and check to see who's filling out this form. Wow, I'm seeing all sorts of people are filling out the form. Wow, thank you very much, everyone. It's really nice. We've got 86 people. Wow, 86 people. All right, I'm actually getting a message from the outside world, outside my blue box that I'm stuck in, that we have some winners from the earlier practicum slides. So for the web developer course, we have Gabriela. I'm going to spell your last name because I have a complicated last name. I'm not going to try to pronounce it. Baranciuc. Just shout out in chat or send a direct message to Linda saying that you are here so that we can make sure that gets over to you. All right. For the data science course, we have Jared. Please ping Linda, say you're here. And for data analysis, we have, oh, wow, I thought I had our name. ANGGAAGIA. Again, ping Linda and tell them you're here. Just so you know, my name is Rainer Pasquis. I have a complicated name too. I feel your pain of having a long and interesting name. All right, I'm seeing some people, unfortunately, filling it out with DevFest20 as the form name. Well, you're definitely paying attention, even though that's not the right thing, so don't worry about it. All right, then we're going to let this run for another. Let's see. We've got almost 100 people in here. That's pretty nice. And Linda, she's saying congratulations. You guys like this blue box? Should I stay? I don't know. The blue box is nice. It's better than most apartments in the valley. All right, Mark, if you look at the screen, you'll see the URL or QR code. I'll use your name, your email address, which I hope you have, and the passphrase for today. Today's passphrase is technical difficulties. Technical difficulties. All right, so we're going to take and run this for another 5 minutes. I'm going to set my watch here for 5 minutes. I'm seeing some interesting things happening in chat. The tech, yeah, we are having the techiest of difficulties. Of course, by saying that now, watch, my camera's going to die. It didn't die. Okay, we're getting a little bit better off. So, in another 4 minutes, on the screen right here next to me, where you guys see the QR code and link, you will see a wheel that will spin. And with that spinning wheel, we will find out who wins what. And I'm seeing more and more people still filling out that form. Wow. Remember, you have another 3 minutes. That's right, 3 more minutes until you too could win something here at DevFest Northeast 2020. Just gotta check your chat, see what everyone's saying. And Linda's calling out in chat some more people who win the practicum prizes. Just shy of 100 people in the raffle. That is pretty impressive. I hear people asking for the O'Reilly, how to sign up for it. So there will be, everyone gets a, everyone who attended today will be getting a free O'Reilly code. The code is DevFest20, and Linda will hopefully post the URL in just a second. If not, I will jump out of frame and type that in for y'all. If everyone wants to know my costume is someone who isn't having technical difficulties. All right, let's check that timer. We have just over 1.5 minutes, 1.5 minutes until the raffle closes and we start spinning the wheel. Oh, and seeing some more people filling out the form. We have broken the 100 people mark. Wow, I am really thankful that you all show up today. Yes, the coupon code for O'Reilly is DevFest20. The URL for O'Reilly should be in chat relatively soon. Can't stand that far back. There you go. And if you all look in chat, you'll see a message from Linda. The URL for O'Reilly is O'Reilly.com/get-learning, code DevFest20. Again, that's O'Reilly.com/get-learning, code DevFest20. All right, everyone. And that right there means we're going to close our raffle. Just give me a few seconds to work some magic. Some Halloween magic. Oh, wow, that's a lot of names. Okay. Hope everyone's ready for some really fun things. All right, so you all can see this. See the link? Can you all see it? Slowly spinning names. Slowly spinning names. All right. So just gonna pull up my handy list of everything that we're giving out today, which is a lot of stuff. I mean, I just, oh boy. Okay. So to start things off, we're gonna give out a free O'Reilly book. And for first O'Reilly book, spin the list. And we're spinning. Wei Yu, Yao, I'm not sorry if I'm butchering names. You are the first winner of our raffle. You will be getting an email later on today, tomorrow, sometime around that, to take and claim your prize. Okay, it's one O'Reilly book. Giving out a full 10 books. So for the second O'Reilly book, spin, spin, magic wheel. Amy Lamb, you are getting a book from O'Reilly. Again, we all know that there's no way for us to figure out how or what wins or book covers. Game reports that people aren't seeing who won. Oh, sorry about that, everyone. Technical difficulties are technical difficulties. Can everyone see the wheel? I'm going to wait a second until I get confirmation from chat that you all can see the wheel. Everybody see the wheel. So far we've had 2 people win. If you could. All right. Next winner. Guillermo Martin. Guillermo, congratulations. You get the 3rd O'Reilly book. So Amy Lamb, Way, Guillermo, you guys are getting books. Congratulations. Now, the 4th book, actually. 4th book. I'm going to count properly. Control. Enter. Spin, spin, magic wheel. And your name moved too quick, Andres. I'm sorry. I didn't get your last name. You're getting a book. Another book. That's 4 books. This is our 5th book. Wow, getting out a lot. We should be a library. We're getting out books. There we go. Spin, spin, spin. Our 5th book, people. Sukat, I'm not going to try to pronounce your name. I'm sorry. You're getting a O'Reilly book. Getting some information. Apparently, people can't see the wheel. So, fortunately, you're all going to not be able to see my wonderful face. So we can see the wheel better. So this is our 6th book. Our 6th book. M. Gundel. M. Gundel, you are getting an O'Reilly book. And yes, I am counting on my fingers. Check in with next one, 7. Number 7, magic number 7. For our 7th O'Reilly book. Margaret Harrison, you are getting an O'Reilly book. Can I suggest a good one? Huh, what am I talking about? They're all good. Number 8. Who will be number 8? Karen, you are getting an O'Reilly book. All right, now for our 9th O'Reilly book. Gabriella, your last name flew by too fast. Sorry. But you're getting a book. Hope that makes it better. And for our last O'Reilly book of the day. Mama, your last name was so big it couldn't spell it out. You are winning a book today. All right, that's our 10 books. And just a reminder to everyone in channel, if you showed up today, if you can hear the sound of my voice, then you qualify for 33 days at O'Reilly Books. O'Reilly.com/get-learning. Use the offer code DevFest20. Again, that's offer code DevFest20. All right, so, well, before we give out our wonderful sponsors, now, ROI Training. That's right. Our next sponsor is ROI Training. We have giving away 4 certification training classes for them, plus 10 $50 Google Play gift cards. So let's start off with the 4 on-demand training classes from ROI Training. So the first ROI Training winner is spin, spin, spin wheel. Jared, you don't have a last name, so hopefully there's only one Jared. Jared, you are getting one of the ROI Training courses on demand. For our next ROI Training course, that name was back. I'm trying to read it backwards in the own stream. You are winning an ROI Training course. We have 2 more training courses to give out, everyone. 2 more. And this is for our third ROI training course. Tutor Ralph, you are getting an ROI training course. Tan Du Tran, you, I hope I didn't get your name wrong. If I am, I apologize. You are getting an ROI training course. You know what? Because I'm definitely butchering people's names, I give everyone in this channel permission to butcher my name. If you see me at a conference, on the street, at the job, butcher my name horribly. That way, we're all in this together. All right, we're going to take a quick 1-minute break while I confer with everyone backstage and make sure that we're not getting things out to everyone. All right, everyone, and we're back with more fabulous prizes for you wonderful attendees. So we've just finished giving out four ROI training certificates. And now, because ROI was really generous, we're going to give out 10 $50 Google Play gift cards. That's right, 10 Google Play gift cards. And the first Google Play gift card winner is again, I'm not going to try to butcher your name, but you just won a Google Play gift card. All right, and now our second Google Play gift card goes out to Adam. Adam, you are winning a Google Play gift card. Now, our third Google Play gift card, brought to you by O'Reilly ROI Training. Ahmed, I'm hearing that someone has won twice. Ahmed? Hold on. We have to figure out that someone twice. Sukagas, I am being told that you have already won, so unfortunately you're not eligible to win again. So that means we have another gift card to give out. So Adam Ackmead, you're still good. Spinning for another $50 gift card brought to you by ROI Training. Stephanie, you're winning a gift card, assuming that no one tells me that things went wrong. All right, now to give out our fourth $50 gift card brought to you by ROI Training. Zoe, you are winning a $50 gift card. You got 4. All right, and now give out our 5th ROI Training gift card. Right, these are Google Play gift cards, not gift cards to ROI Training. That was a different raffle. Mark. All right, just give us a moment, everyone, while we get the ROI stuff mostly settled, and we'll keep on going. You know what? We've been giving out gift cards for a while now. I think everyone's a little tired of gift cards. So why don't we move on to Dan Sullivan? So Dan Sullivan has graciously donated several of his courses to someone here in chat today. So we're going to start off. We have 3 Associate Cloud Engineer and 3 Professional Data Engineer courses. For the first Associate Cloud Engineer course, we are going to spin the wheel for Sudhir Rao. I need to check that name. I think you already won something. You did, Sudhir. You have already won ROI Training, so unfortunately, you're not eligible to win again. So again, this is for our first of Dan Sullivan's courses. Nihan. You have won Dan Sullivan, one of his courses. We are offering 2 of the courses. You are winning a Associate Cloud Engineer course. Congratulations. And now for the second Associate Cloud Engineer course in the Raffle. Hendrik Beck. Beck, let's double check you haven't won something already. You have not, so you are winning one of Dan Sullivan's courses. You're winning the Cloud one. Cloud Associate. All right, and now for our final Associate Cloud Engineering course from Dan Sullivan. Gabriel, didn't you already win something? I think you did. Let's double check that. Gabriel, you already won a O'Reilly book. So unfortunately, you cannot win more than one book with us. So I'm going to have to spin again. And Karen, you won something already. Hang on, you have not won anything yet. So guess what? You are getting a Dan Sullivan training course. All right. So we're going to take a quick break while we confer with Backstage. All right. Can everybody hear us? Well, I guess choosing technical difficulties as a phrase for today was a good idea. All right, and we are back. You may not see your name on the page, everyone, because it's we have, as last count, 115 people in the raffle, and well, that's a lot of people. All right, so now for our second Dan Sullivan data engineering course, the winner is Imran. Imran, you are a winner, assuming you haven't won anything else already. You have not. Just copy your name down. All right. Now for our final Dan Sullivan course. Clem Allison, you are getting a Dan Sullivan course. All right. And so that concludes all of the wonderful gifts from Dan Sullivan that we got. Thank you, Dan, for donating those for our DevFest. It was really nice of you. And now on to Wellframe. Wellframe has a $50 Amazon gift card for our Raffle today. Only the one, but that doesn't really matter. All right. So this is for the Wellframe $50 Amazon gift card. Spinning the wheel, spinning the wheel. Omar, double check to make sure you are not winning twice. You are not. So guess what, man? You are getting a gift card. It's Fly Plus Save by Wellframe. All right, we're going to take a quick 30-second break while I confer with people backstage, and then we'll move on to JetBrains. All right, I'm being told from people behind the curtains that I actually have 2 more gift cards to give out from Wellframe. That's right, 2 more Wellframe $50 Amazon gift cards. So let's see who wins those. Who wins? Pluralization's hard. All right, and the second of the Wellframe cards is going to go to all right, we're just going to check to make sure, man, you have not won it. So you're getting a Wellframe card. Congratulations. That's, I'm going to just spell your name because it's about as complicated as my last name. Anjaneya. You have won a $50 Wellframe Amazon gift card. Terms apply, you know, all that standard stuff you're seeing. Now the final Wellframe gift card. It means, Sage, haven't you already won something? No, actually, you have not. All right, and that concludes our Wellframe gift cards. We're going to take another 30-second break while we confer backstage and then start into JetBrains. All right, everybody, and we're back. Sorry about that little delay. We're just making sure that we actually can give out what we say we can give out, or that we have enough stuff to give out, because, you know, that could always be a problem. All right, then. So now we have 3 JetBrains license keys, 1-year subscriptions to one of their products to give out right now. So the first of our JetBrains licenses is going to Danielle. Danielle, we're going to just confirm to make sure you haven't already won something, because you have not, Danielle. So you are taking and getting a JetBrains license key. You'll be getting that via email. All right, now for our second JetBrains licensing key. Jay Burnett, you are assuming you have not won something else. You have not. You are getting a JetBrains licensing key. Now for our third and final JetBrains licensing key. Okay, I thought you already won something. You have not. Congratulations. Didn't you win something from Practicum? You did. You won already from data analysis from Practicum. So you, unfortunately, are not eligible for JetBrains. So I'm going to spin the wheel yet again. Spin, spin, spin on a magical wheel. Jared, you already won something. You already won some wonderful ROI training. You can't win things twice. And so you are winning a JetBrains licensing key. That's 1 year licensing. All right, everyone, we're going to take another quick break while we confer backstage and then move on to the next giveaway. All right, everyone. So we're coming up on the end of our raffle, the end of our time together. So we are now going to give out 2 $50 Amazon gift cards from Gaspacio. They were fine enough to give us some stuff to give out for today. All right, and the first person to win a Gaspacio $50 Amazon gift card is Alan. Alan, you have not won anything yet, so you're getting a Gaspacio Amazon gift card. All right, and for the final Gaspacio Amazon gift card. You have not won anything yet, so you're getting an Amazon gift card as well. All right, we're going to go on one little break and see what's left. And then, well, that will be that, as they say. All right, everyone. So we were talking backstage, and I do believe that is the total of what we're giving out today. Again, thank you, everyone, for showing up for DevFest Northeast 2020. Yeah, we had some technical difficulties, but I think overall we had some really great speakers today with some really great information. You will be getting a form in your emails, hopefully later today, tomorrow, sometime like that, asking you to give us some feedback. Please give us your unbridled feedback. We want to know exactly what we can change for next time and make sure that things are always awesome. I hope everyone has a wonderful day, enjoys the full moon tonight, which is fairly auspicious considering the date. And stay safe out there. The world's a crazy place.